Big data analytics helps organizations harness their data and use it to identify new opportunities. That in turn leads to smarter business moves, more efficient operations, higher profits, and happier customers. And Hadoop is changing the perception of handling big data, especially the unstructured big data. Apache Hadoop enables surplus data to be streamlined for any distributed processing system across clusters of computers using simple programming models. Understanding this, we have come up with this Big Data Hadoop tutorial for beginners. Now, before we go ahead with the session, I'd like to inform you that we have launched a completely free platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below. Now, let's have a quick glance at the agenda. We start out by understanding about big data, then we'll learn about Hadoop.
So today we will be covering big data, what exactly is big data, and then we will look at something called a Hadoop ecosystem and Hadoop architecture, basically. So these things are the foundation for all your machine learning, statistics, Spark, anything that you are learning, the foundation is this. So today we will be understanding big data and Hadoop ecosystem. We'll ensure that we go through all the basics and all. So my name is Raghu Raman, you can call me Raghu. I have been in the IT industry for about 12 years as of now. And I have been working on big data platforms for about 7 to 8 years. From 2011 onwards, I started on big data. I train people on Hadoop, Spark, the big data typical tools that we use. I train a lot of people from corporate backgrounds. I'm a regular trainer at Flipkart, GE, EMC, and many other companies. The definition of big data, if you Google, you will get. First thing, you can just go to Google and say, what is big data? You will get tons of articles, PDFs, and presentations. That is not what I'm going to teach you, right? What I'm going to teach you is that, let's take a practical use case, right? Let's take a practical use case and try to understand how big data actually makes sense, right? So, first of all, big data is related to IT. So, you need some level of IT knowledge to be fair, right? This has something to do with IT. I will share my personal experience, okay? So, when I started working in 2007, 2008 and all, okay, I was working with a company in Bangalore, and we had created an application, a sales application. So, basically what we'll do, if you install this application, there was a retail company, the customers will input all their sales data in that, so they will say that today this much quantity item sold. Sold and sold and sold, and this application will capture all the data, okay, and store it. Now that was a very simple world. We did not had mobile phones, we did not had Facebook, WhatsApp, nothing was there. 2005, right? And we were using an RDBMS system to store this. You know what is an RDBMS? Okay, at least you are good at that, right? So this is your culprit. We are not going to use this kind of big data, okay? So RDBMS is what we were using to traditionally store the data, right? And what is an RDBMS system? It has a row column format. You have a table. You insert the data. Now, if somebody is teaching you RDBMS, they will say that, well, RDBMS is great. It can store everything, that's all fine. But unless your data starts increasing, right? So originally, RDBMS can store everything. I don't have any, I'm not against RDBMS or something. Even for transactional management, we use RDBMS. There is no doubt about it. MySQL, Oracle, we were using MySQL actually. So whatever the customer is inserting, this MySQL will capture it. End of the year, you do some processing. You will understand how many items were sold. Everybody is happy. This is what was happening in 2005. Fast forward to 2011. I am working with ICICI Bank. ICICI Bank want to migrate to big data platform. So 2011, we run a project in which we migrated the entire ICICI Bank into big data platform. Okay, so I was part of that project. I was not doing everything in that project. So what is the problem with ICICI Bank, right? So that is the question. Why ICICI Bank want to go to big data, right? Now, this example will also help you to understand the IT world, right? So for people who are not coming from the IT background, they might need to understand how things are working, right? So we went to ICICI Bank, we spoke with them, we said, hey, what do you want? They said, you know what, we are facing a lot of problems. We want to go to big data. We want to go to Hadoop. We'll see what is Hadoop later. So we asked, what is a big deal? What is your problem? So there were a lot of problems which they were facing. One of the problem is that if you look at this RDBMS system, right? Your typical RDBMS system. What is the RDBMS systems doing? They will store the data in the form of a table, right? Now, if your table size is very, very small, it's not a big deal. Even if you look at MySQL or if you go to enterprise scale Oracle and all, they can store gigabytes and sometimes up to terabytes of data. But as the size becomes big, so let's say I ask you, okay, you have to store the data in Oracle. The data is keep on increasing every week. You are not ready to migrate anywhere. Oracle, if you talk only about Oracle, they have storage separate and DBMS engine separate. I don't know how many of you have worked extensively with Oracle. In Oracle, what I can do, I can purchase Oracle and I can add storage boxes, as many as I want. So these boxes will be in the network. So my database engine will be connecting to them and storing the data, whatever data I am giving. So you can argue saying that I can increase the storage capacity and then Oracle can store as much data as you want. There is no doubt about it, right? But there is also a limitation for this storage, one problem. Second problem is that as this box increases, the storage in Oracle increases, you have to divide your data. You have to partition your data. So let's say, for example, you are working with Oracle, okay? So let's say you are working with Oracle and let's say we are looking at iPhone sales. iPhone, right? So you are selling iPhone. Let's say you are working with Apple, right? So one of the example is that if you are creating tables to store iPhone data, typically if you look at the schema and all, what we will do is that there will be one table, okay? There will be one table wherein you will be having properties like, how many items were purchased, at what rate they were purchased, how many people bought, so on and so forth. So this will be your items table. So in the items table, you will have all the data related to the iPhones you were selling, right? You will also have another table where there will be the user data. You will also have the user data. User data means which customer bought, from where he bought, all this data. This is called normalization. You know what is normalization? In RDBMS systems, in order to avoid duplication of data, what we do is that we normalize the data. We always keep the data in different tables. And whenever you want to get the full data, what you do? Joins, right? So if I want to get both the data from this, I have to do something called a join query. I fire a join query and all the data from here will come and join and produce me the output. This is good if you are having small amount of data. What if you have terabytes of data here and here? My join query will fail, right? Or the join query has to wait. Now another point that people say is that if your RDBMS is becoming bigger and bigger, why don't you partition your data? That is possible. I can have like 4 boxes. My one table, okay, if this is my table, right? It can be logically partitioned and kept on 4 machines if it is becoming bigger and bigger. Okay, this is possible. There is something called logical partitioning. Look at the iPhone data. I can say all the data where people from India are buying the iPhone, go to this machine. That's called logical partitioning based on the country column. So here I have all the India data where people are buying iPhone. Here I have the US data where people are buying the iPhone. But the problem is here I'll have the Burma data also. India data will be, let's say, 2 terabyte. China data will be 3 terabyte. This will be KBs actually. So the problem is that if a table is becoming so big, okay, I can cluster it. I can take 4 machines in my RDBMS or data warehousing architecture and I can say partition the data. Because if a table is so big, if I fire a query, the query will take a lot of time. So what I do, I say that, okay, don't store the full table, divide the table or partition the table. To partition, I will say that you have to use some logic for partitioning. I cannot physically divide the data. That's not possible in RDBMS. I cannot say that take a table and cut it into 4. Doesn't work. So I have to logically partition. So I have to say that there is a country column. How many countries are there in the world? Maximum 155, right? I'm not much of a geography person, but I think somewhere around 155, right? Or at least people who buy iPhone, 155 countries are there. So I will say take the country column. So everybody who is buying an iPhone will have a country column. So based on the country column, it will partition your data. right? Now I have 4 boxes. This box has India data, US data, Burma data, and something data. Again, same story. If you are running the join query, this box has to process all the India data for join query. This box will complete very fast. This guy has to wait. So again, so the problem is that traditionally people were using RDBMS systems and data warehouses to store the data. Now what is the drawback? One of the drawback is that as the size of the data increases, your processing will become very, very slow, right? You can't do it. Now, the problem with classes in big data is that there are a lot of technologies. So when you start talking about them, why don't you denormalize the data? Why don't you denormalize the data? For example, all the transaction data, user data, everything I'll keep in one table. Is that possible? One duplicates. Second, what is the maximum number of columns you can have in a table, RDBMS table? 1000. Oracle says 1000. What if my data has more than 1000 columns? If I keep all the data, I can't do. So that is the reason they don't provide the denormalized solutions. If you look at RDBMS systems, they will always say normalize your data so that it will be represented in different tables, and whenever you need the answer, you do a join and you get the result. Second drawback, this is only structured data, meaning anything which you can represent in row column I can dump here like an Excel sheet data, right? Can I dump images and audio files in this table? Yes or no? Can we store unstructured data in RDBMS? Yeah? Yes, you can. There is CLOB, blob and all objects, right? But can it process unstructured data? Not possible. So, in the modern day, if you look at the modern day, what is our problem? So, if you look at a typical bank like, so let's first complete this part. So, one of the drawbacks of RDBMS is that as the size of the data increases, it cannot cope up with processing. One of the problem, right? Second problem is the schema, meaning anything which you can represent in a row column format, I can dump in an RDBMS. Anything apart from that, I have to figure out a solution. So what is the actual solution if I have to store images and retrieve them in real time? How does Flipkart stores the data? I was working with Flipkart for some time. Flipkart has around 10 million products. Each product has 10 images. That is 1 billion images. So when you click on a iPhone X picture on Flipkart, Flipkart will say that come after 10 minutes or immediately display. Have you ever thought how it is happening? Good question, right? How it is happening, right? So do you think they are dumping in an RDBMS and picking it from there, 1 billion images? No. NoSQL databases. There is a whole arena of databases called NoSQL. Fortunately or unfortunately, it is not in my course, so I don't have to teach, right? But if you are going to, so your end goal is to become data scientist, and I think that is why you're learning this course, right? You're learning Spark and other things, right? So I would suggest you to Google and learn a little bit about something called NoSQL databases. If you have heard about MongoDB, Cassandra, HBase, Neo4j, Voldemort, these are all popular vendors of NoSQL database. So NoSQL databases will help you to store and retrieve unstructured data at any speed you want. So what Amazon.com actually does, Amazon has something called DynamoDB. DynamoDB is a NoSQL database. So in DynamoDB, I don't have a row column. I have key value pairs. So what they do, the key will be the product name. Say you are clicking on iPhone X. iPhone X is the key. The value will be all the data you have. So the moment you click, boom, your page is there. So NoSQL databases are really faster. Also, it helps you to store unstructured data. How are you booking a cab using Ola? Right? I go out. I didn't get a cab yesterday, by the way, in Chennai. But if I try to get a cab using Ola, right? I open up Ola. How many customers Ola has? Millions in India. And all of them are booking at the same time, right? Do you think all your requests are taken by an RDBMS and searched in the table and give you a cab? Does it work? Can an RDBMS system handle 30 million, 40 million concurrent sessions on this amount of data, calculating route? MongoDB, NoSQL database. Ola runs on MongoDB. I was working with Ola for one of their design problems actually. So I didn't design anything, but they told me that they are using MongoDB. So the problem is the new world that we see today does not fit our old description. When I went for my first job interview in 2006, my technical guy who interviewed me asked, what is your strongest skill? I said Java. He said, you're selected. Because Java is like, if you know Java, you will get a job without an interview. Now if I say Java, he will not allow me to sit in front actually. Because Java is still good, but the new world demands new skills actually. That is my whole idea. So the second drawback of your RDBMS is scalability is there. Okay. Third is price. Price is a problem, right? Obviously if you calculate the cost, if you look at Oracle and all, they are very, very costly solutions. ICICI Bank was paying around 30 crores only in support fees to Oracle. 30 crores, not even a year. I think 3 months they were paying 30 crores, 40 crores only for support for Oracle, because it is an enterprise grade product, right? You have to pay money. There is no other way, right? Now, if you switch to NoSQL platforms, they are all open source. You don't have to pay this much amount of money, but that's not our discussion. I'm just saying. So all these problems means traditionally storing the data on an RDBMS and retrieving is not good for the modern day. In the modern day, what is happening is that every company want to collect and analyze the data. Be it banking industry, e-commerce industry, or any industry that you want, they want to collect and analyze the data. So to give you an example, if you visit Amazon.com or Flipkart.com, what is happening? They start tracking from which IP address you are visiting the website, how long you are clicking on a page, which items you are adding to cart, which images you are clicking, which offers you are clicking. All this data is analyzed to understand how a customer will behave. That is how they do marketing, right? So the more you start visiting the e-commerce companies, you start seeing recommendations and all the more. The more you visit Amazon, they will start recommending products to you, asking you to buy. So they have to collect all this data. So when I was working with Flipkart, Flipkart said that they collect data from the apps that you are using, from the website that you are having, even from social media. Flipkart is very active in social media, like Facebook, Twitter, all these places they are active. So if anybody tweets about Flipkart or visit their Facebook page, all this data is being collected. Now this is actually called a big data. So the technical definition of big data is this: huge amount of data which you cannot process using your traditional methods. That is called big data, right? So why that is of interest to us? We are going to figure out how to store this data, huge amount of data, right? And how to process this data. So using the traditional techniques, you will not be able to store it or process it. That is not possible at all. So we will be seeing how you can use Hadoop as a solution to store all this data and process all this data, right? So interrupt me anytime if you want to ask anything. I'll keep on talking. Yeah. So when I say NoSQL databases are there, it does not mean your RDBMS is gone. So many people ask this question. Okay, RDBMS is the only solution for transaction management. So even if you're buying something from Flipkart, who will complete your transaction? Oracle probably, or any transactional system. For transactional management, and why is that? Because RDBMS systems are the only ones which can ensure the ACID properties, right? If a transaction goes or not goes. You bought something from Flipkart, tomorrow Flipkart cannot come back to you and say that I don't know whether the transaction happened or not. Probably you got the money. It's not possible, right? Then you will start complaining against Flipkart, right? So Flipkart comes to you and say that, you know what, we are using Cassandra. As per Cassandra, your transaction is, we don't know, we'll come back to you in another 1 week. Is that possible? No. So transaction management, very good question, is still handled by RDBMS. Technically, it is called polyglot persistence. So I'm not a person who uses a lot of technical words, but polyglot persistence. That means coexistence of traditional databases and the other ones. Even if you look at Amazon or any company, they will have their transactional data and a bunch of NoSQLs to handle other type of things. Okay, polyglot persistence. Well, you don't have to really. I'm not a person who really use a lot of what you say? Polyglot persistence. Persistence is E or A, I don't know. Even my English skills are at stake when I'm training people. Persistence is E, I think, right? What do you think? Take a vote for that probably. No. Yeah, so that's what. We have not come to Hadoop so far. I will explain. Hadoop is not a database. So teaching big data in 16 hours itself is a challenge actually, because it's a vast topic actually. In the world of big data, there is a separate category of systems called NoSQL databases. And they are databases. So what does a database does? Real-time queries, right? And in that area, we have MongoDB, Cassandra, HBase, and these guys. Now these guys are used in real time if you want to fetch the data. Say for example, you are opening an e-commerce website, probably it is given by a NoSQL database, right? Or millions of people are booking flights through cleartrip.com, and Cleartrip has to identify how many people are booking in a particular route so that it can give a better offer. This is probably done by reading real-time data from a NoSQL system. Our area is not NoSQL. NoSQL is a DB actually, it's a database. Our area is not NoSQL. We will come to Hadoop, right? Now, so this is the technical term for coexistence of DBs and NoSQL and all. So now let's understand. So we established the idea that RDBMS is not good for us, at least in the world of big data. But don't say that RDBMS is not good, because transaction management is still handled by RDBMS. So you cannot say that get rid of RDBMS, right? Now there is a very important term, even though it is not directly related to your syllabus, but I think it makes a lot of sense. How many of you are aware of this term? Raise your hand, I will raise. Oh, a lot of ETL guys, good to know that. So you know what is an ETL, right? And some people do not know what is an ETL, that's fine. So ETL stands for extract, transform, and load. So what is the idea here is that, see, if I'm working with a company, right? The company will have RDBMS systems, right? So these are all RDBMS systems. So probably this guy is using MySQL, and he's also using Oracle, right? A lot of RDBMS systems are being used by a company, right? Now these are all serving the customers. So if you take the example of ICICI Bank, all their core banking data is in Oracle. All their core banking data is in Oracle. So if you are making an online transaction, the data hits Oracle. All their CRM data is in MySQL. What do you mean by CRM? Customer relationship, right? Your name, address, blah, blah, blah. So they have these two type of data. Now, is this the only type of data that they have? No. ICICI Bank had also acquired a lot of other companies when we were working with them. So their subsidiary companies were giving them data in the form of XML files. XML, right? Now ICICI Bank also had a Facebook page, okay, from where they were getting around 10,000 people visiting every day that Facebook page, and they used to click on some item. So they have to do this cross-selling, upselling. If a user goes to Facebook page and say that I really like your loan, take more loan, right? So that is your cross-selling and upselling, right? So what they do, they collect all this data from social media. That comes in the format of what? JSON. JavaScript object notation, JSON, key value pairs basically. So this is where their core banking data, this is where their CRM data, this is from their partner companies, this is from the social media data they are getting, okay, and they had customer care. This one, the social media data, they want to do analytics. So every day 10,000 people are visiting their web page. They want to know a person clicked on, let's say, a loan offer and how much time he stayed on the page and what age group he belongs to, so that they can recommend products. Recommendations actually. A lot of recommendations. So social media data was being used. They did not reveal all the things that they are doing because that were internal to, but basically using the social media data, they were doing recommendations. So they will download all this data. So if a customer is clicking on the Facebook page, they will get the access of this guy. If you are clicking on ICICI Bank's Facebook page, they will know your age, your occupation, everything you shared in Facebook. That is by default given to me. In most of the cases, you can restrict the information, but most of the public customers, they will share this. So by downloading this data, today they will understand 10,000 people clicked, and out of them 5,000 were youngsters, and they clicked on this loan. That means the trend is towards a particular bike loan. If we give an offer on bike loan, youngsters may actually buy it. So this is analytics, right? So all the social media data they can use in multiple ways actually. So this was getting in the JSON format actually, and this type of data was there. They also were collecting their customer care log files. So that is again flat file. It was coming in a format of flat file. Flat file means text file. So customer care log actually means the chat logs that they were having, also the call logs. They don't record, they don't get the actual call, but how long the call happened and what you pressed. So when you call customer care, you press, right? This. That is actually captured. And then they want to figure out how many people are called on what category, how much time they spent, right? So if you have clicked on a complaint button and you talk for 1 hour, chances are very high you are a bad customer, right? I mean, 1 hour you're scolding probably, right? So they want to figure it out, right? So that is the call record that was coming in flat file, this format, right? And at that point in time, ICICI Bank also wanted to offer a solution. So previously what they used to do, their agents were there, people who go to your house and make you buy loan and all. So they used to go to every place. So this agent will get a list and he will go to that place and he will go to your house and say that, sir, please take a car loan. You will say no, he will say buy. He will get money. He is getting salary, right? So this technique was not working because if I get a list, okay, one customer will be in here. This is what place? Vadapalani? No. This is OMR, right? One guy will be in OMR, another guy will be in some other remote place in Chennai. So by the time he travels from here to that place, day will be over. So he is able to cover only 2 customers. So what ICICI Bank had in mind, they will track his location. He has a device, okay, and give him customers in real time. So if he is in Kannanjavadi, he'll get all the customers nearby him. So this guy has to go, right? He cannot say I can't go. So he will, the customer application, it was a tablet, will track this guy, and wherever this guy goes, the nearby customers will be provided to him. So he can cover more customers, right? And this has a lot of impact because why it was practical, because sometimes the customers will call and say that please come, I'll give you a loan. So what you do from here, you might travel to, there is a European city, Paris in Chennai, yeah. So you will go to Paris, right? And because the customer called, right? So you go to Paris and meet the customer. Now you don't know how many customers are around Paris. That this application will track and send it to you. So these guys were collecting that data also from all the tabs, and that was quite some big amount of data they were collecting. So how many customers they met and whether they closed it or not closed. Okay, that was coming in, I think, some other format. So some format I forgot actually how it was coming. So this is the whole data they have, right? And some more data was there, and this data is lying on different systems. It's not in one place. The core banking data is in Oracle, some other data is in some other place, right? And if you want to analyze this data, one thing is that I cannot go to Oracle and say that I want to analyze your data. Why? Because this Oracle DB is already busy serving customers. Correct. This Oracle DB is the core banking database. So if you are making a transaction, Oracle is handling that, right? So I cannot go to Oracle and say that let me run some analytics on your data. Doesn't work that way, because then Oracle will slow down. I can't do that. So I have to take all this data from all these places and dump it into a central place. So that is what is you call as your data warehouse, right? That is called a, how many of you know what is a data warehouse? So a data warehouse is nothing but a database only in one way. It understands the language of SQL, but the major difference is that it is not facing the customer, right? So you will do something called ETL, okay? So there are ETL tools which can get the data from all these places, right? And this guy will dump it into a data warehouse, right? So data warehouse is also called as your OLAP, online analytical platform, so on and so forth. And what is the purpose of this guy? So this guy will have all the data from here, okay, and you can transform the data as well. So that is why it is called ETL, extract, transform and load. You don't just take the data and dump it here, then it is useless, right? I can read the data from a flat file and give some structure and then dump it here, like a proper table format. So now all my data is here from this, right? And I can run business intelligence here, BI tools, Tableau, right? If you have heard about MicroStrategy, Tableau, what I can do, I can connect a visualization tool here and it will show me in charts and diagrams what is happening. I mean, this is traditional enterprise architecture. This is how people used to work forever. I mean, every company you go, this will be there by default. They will have these disparate discrete data sources and ETL tools. So if you have heard about Informatica is one of the biggest ETL tool. Informatica, Talent, Pentaho BI, SSIS. So these are all ETL tools. So these tools, what they do, they will connect with here and take all the data and apply some schema and push it to a data warehouse. Now the data will be here. So now all the data is in one place. So if I am Chandra Kochar, I wish I would be, I can go here. Chandra Kochar is who? ICICI Bank's CEO, right? Who is that place? So I can go here. So Chandra Kochar may not know SQL, right? You can't expect that, right? If you're a CEO of the company, I can't ask you, do you know Java? I'll be fired next moment, right? So, but the CEO want to know what's happening, right? By getting all this data only, you will understand what's happening in the company. But you don't have time to sit and learn all this language or anything. So if I'm Chandra Kochar, I'll go here, I'll connect my Tableau, and I'll ask my Tableau, show me the last month's transaction, this quarter, this product, this area, show me. It will show a nice bar chart. I'm happy. Now, why this is very, very important? If you make any mistake in any of this entire stuff will be changed, right? And what she sees will be different, right? She has no idea how this is happening, right? Only you know how this is happening, right? So your ETL tool should run proper, the data should be captured and dumped here and then analyzed. So for CEOs and CTOs, they use visualization tools to connect with a data warehouse, then analyze the data. So all the data is inside this data warehouse, right? And this is not accessible by public. Public has no access to this. Only internal company has access, like maybe CEOs of ICICI Bank, they can go here and visualize the data from here. Others, public does not have any access to here, right? And then they visualize the data, they make a decision, they may not make a decision, that is up to them, right? In the whole setup, there is no Hadoop so far. And this is how ICICI Bank was running so far. Now, what were the challenges they faced? One of the challenge was that this ETL tool, okay, I don't know how many of you have run on ETL tools, okay? They typically run on a single machine, okay? So they get installed on a server. So there is a limit as to how much this guy can pull to a data warehouse, right? How much amount of data this guy can pull from here to a data warehouse, there is a limitation, actually. You can't have terabytes of data being pulled, point number one. Point number two, none of this is real time. None of this is real time. I go to Tanishq store, Tanishq is a jewelry stuff. I go to a Tanishq store, I buy something from there for 20,000 rupees. I use ICICI credit card. I should immediately get a message saying that again you shop 20% discount. That is real time. I can't do it here because all this is separate data and these ETL jobs run at the night. So today morning if I'm shopping, tomorrow I'll get the message 20% off. By the time I'm out of Tanishq shop, right, I may not use it at all. So ICICI Bank's first problem was that since the data was increasing, they were not able to run ETL properly. Second problem, none of this is real time. They wanted to push customized offers. Their requirement was that whenever any transaction is made, they want to capture it, analyze it, right? And based on that, they have to recommend something to the user, right? Say for example, you're using credit card or debit card, or even you're clicking on some link, immediately something should happen. Now that is not so easy, right? Because your data might be somewhere in here Oracle, and I cannot track each and every transaction here because this is my transactional DB. I can't say that track each and everything from here, right? That's not possible. Third problem, this data warehouse. This data warehouse is a very costly affair. I have worked with a company called Teradata. They are the leader in data warehousing market. I had a US client, they were using a product called Teradata for data warehouse. They were paying around $5 million every year only for this setup. Now it is good, you can analyze the data and all, that's okay, but you're paying a lot of money actually. So data warehousing is actually a very costly affair. It's not so cheap if you want to implement, but companies like ICICI Bank, they must use it, right? So they can't say that we will not use it. So they wanted a cheaper solution. They don't want all their data in this data warehouse. They want an alternate solution. It should be real time, cheaper, scalable, right? And anything they want to integrate, any type of data that comes, they wanted to integrate. And that is how they came to us and asked us, like, can we migrate to some big data solution? And we recommended Hadoop, and then the migration took a lot of time. That is a different case altogether. But if you talk about Hadoop, Hadoop actually comes here. In a way, I can say it is, yeah, sorry.
Traditionally, these OLAP tools are designed for accuracy of the data rather than speed.
Right.
But the online transaction processing,
Exactly.
the throughput time is important.
Right, exactly.
Both are at different extremes.
Right.
You cannot give a suggestion that when the customer
Exactly.
at that time I cannot really do.
Not possible. Not possible.
It's
Not.
the problem of this system.
Exactly. So here you have your n-dimensional cubes and other things, like in the data warehousing. You will have your what you call schema. What schema you call? Star schema, snowflake schema, right? And so this is actually, OLAP is actually not designed for speed. That is true. It is only analytical. It is batch job actually, right? So with this architecture, I can never give a real-time solution.
That's actually a limitation of architecture system. Either you can go on one side or the
Exactly.
you have to find a middle point.
Exactly. So a lot of people argued saying that you can actually beat it if you do parallel processing. There is something called MPP, right? There is something called MPP. MPP means massive parallel processing. So a lot of people came saying that. So these systems are actually Teradata and all are really faster actually. I mean, not like RDBMS, but they are faster. Okay. So a lot of people came up and said that, okay, if your data warehouse is very slow, why don't you do parallel processing? Okay. You install it on 4 or 5 machines and you can do parallel processing. That is possible, but still the same problem exists. You cannot physically divide your tables. Only logical division is possible. Like I said, country based you can divide or month based you can divide. End of the day, if you want to do a join operation or something, same questions will happen. So I can never propose this as a real-time solution. So that is my crux of what I'm trying to tell you. And this is how even ICICI Bank was running. And cost was another problem. They had a lot of cost involved. So, and obviously since they wanted to collect a lot of unstructured data, they wanted to go to a better solution. Okay, and that is how Hadoop came into the picture.
Even the data warehouses can efficiently handle unstructured data?
Not really. Mostly here you have structured data. Mostly structured data only. They are used as the final place where you get the data. From there somebody can visualize. And in here you very rarely you modify the data. You don't modify the data, because this is the place where the final data is available, from where you can connect and visualize the data. That is all you do. Or probably you can run a query and get the output. That is all you do. It is analysis only. You are not doing any transaction. Transaction management, all you are doing here, right? Now, so now the point is that, now let's discuss a little bit about Hadoop. So what I thought is, like, today probably we can cover the architecture and a little bit of theory, so that tomorrow, so if you look at your syllabus that I'm supposed to teach, we have something called Hadoop and Hadoop architecture that is anyway required, right? And then you have MapReduce. Now, there is a catch here. MapReduce is the default programming framework on top of Hadoop. So if anybody want to analyze the data on top of Hadoop, they use something called MapReduce. Point number 1. Now MapReduce came long back, okay, And today there are a lot of ways to analyze the data, not only MapReduce. Now, as per your syllabus, the curriculum says teach MapReduce and then some concepts in MapReduce, and I will be doing that. But one other thing is that if you want to learn MapReduce, ideally you should be an expert in Java, because MapReduce programs are written in Java or any other programming language. So you can write in Python and other things, but natively people write MapReduce programs in Java. Now, I know that not all of you are familiar with Java and comfortable with Java. So if I talk a lot about Java, it may not make much sense out of you. But then why you are learning MapReduce is to help you in Spark. So next you will be learning something called Spark, right? 16 hours of Spark content will be there. Spark also uses similar concepts as MapReduce. So even though you are not able to understand each and every line of code that I am writing, that's okay. But you need to understand the logic, how it is working. Because Java programs, not everybody will be able to follow and understand and debug. So that is not expected also from you. But if we discuss MapReduce, I write a MapReduce program and we run a MapReduce program, you should be able to understand what is happening inside that, right? Logically, not like syntax wise, line by line wise, right? So once we complete Hadoop architecture, like tomorrow, I will be discussing MapReduce theory and MapReduce programs will be running. And then in the next 8-hour syllabus, we will be completing bit of MapReduce and going to something called Hive, Apache Hive. So Hive is your data warehouse in Hadoop. So that is more of SQL side. So you can understand that point. Yeah, somebody had a question? Sorry. Someone asked a question in the middle. I just said I will complete. Who asked? Nobody asked? Okay, I mean, so just rub this, right? Now, what I'm going to do, I'm just going to delete this part for the time being. Okay, I'll just remove this part for the time being. Yeah.
In the enterprise architecture, they will have both the data warehousing and the big data, or they will migrate from
That's what. So now what is happening, the traditional data warehouses are there, like Teradata and all, but they are not so popular. And in the market, like people used to say, if you cannot convince, what you do? You confuse people. And it is very easy to do that, right? Because why am I saying this? Because I see a lot of people getting confused. Because so when Hadoop came, Hadoop became a very popular solution for data warehousing, right? And since Hadoop is open source, and you can read the McKinsey report, it will be only 1/4 of cost of a traditional data warehouse. So what will happen? Everybody will use Hadoop, obviously. Why should I pay extra money? But then what is the drawback? The traditional data warehousing companies, they cannot sell, right? So if today you go to the website of Informatica or even Teradata, they will say that we are selling Teradata plus Hadoop. Previously, you had to give me $10 million. Now you give me 9.5. Take it. Well, that's useless actually, because why should you buy Teradata? But they are saying because Teradata has a name in the market. That is a different thing, right? So Teradata will say that buy our data warehouse, we will also give you Hadoop. That too cheaper, right? Previously you paid us 10 million, now pay 9.5. You're like, okay, great solution. I'm getting Hadoop also. You don't actually need to use Teradata. You can build a custom solution, but the couple of problems are that one, the name of the company like Teradata and support also from them. Second, it takes a lot of time to migrate to these things. One fine morning, you cannot go and say that, okay, from tomorrow onwards, we are using only Hadoop. Doesn't work like that, right? In a company, you need time to do migrations and processes and all. So people stick with their traditional tools. So what I have been saying in some of the companies where I went for consulting, they have completely migrated to big data platforms like Hadoop, and they keep Teradata and all in a very less level, like the hot data we call, right? Hot data, cold data, warm data we have. So the immediately accessible hot data will be there in Teradata and all, and you have the cold, warm data which you don't need to immediately analyze. You will dump it into Hadoop or something and keep it. So you can reduce the overall cost in this architecture, right? So now speaking of Hadoop, our architecture is here still. I just changed a little bit. Okay, I'll just write it here. The question is when all this happened, right? So a lot of people, so I handle a lot of trainings in Hadoop and Spark. So a lot of people ask me that, okay, so we are learning a completely new technology called Hadoop. And I will say that you are wrong, because Hadoop came in 2005. So almost 13 years now. So it's almost like very old, but for people it is still very new, for those who do not understand Hadoop. So in 2005, this framework called Hadoop was created, okay, long back, right? And there were two guys called Doug Cutting and Mike Caffarella who created this framework. They took the original idea from Google. So Google was already doing a lot of distributed computing, and Google was dealing with a lot of big data, right? So they published a couple of white papers, and this Doug Cutting and Mike Caffarella, they took the idea from Google and then created a framework called Hadoop. And later they gave it to Apache as an open source project. So Hadoop is a open source project actually, which means it is with Apache right now. You can download it for free, install it for free. You don't have to pay any money. But if something is really free, you have drawbacks also, right? Correct? For example, you have Android phones. I have an iPhone. I used to use Android phones, but you know the difference, right? The difference is not show off. That is not the difference. The real difference is that Android phone might get a lot of bugs which may not come in an Apple phone. If you have used both, you will understand. The problem is Android is open source, right? And open source means every company will modify according to the requirement. As Samsung phone will have their own Android, right? So accordingly, a lot of bugs may come. The platform may not be so stable as it is. If it is an Apple phone, only Apple produces it, right? And if there is a bug also, if I call Apple or somebody call Apple, they will fix it, because there's only one version of it available, and they know what bugs may come, may not come. So the same story here. Originally it was Apache Hadoop, and even still you can go to the Apache website and download Hadoop. But soon people realize that if they are using Apache Hadoop, it is open source, but if something does not work, something crashes, nobody is there to fix it, because it is open source. And accordingly, a company called Cloudera came. There is a company called Cloudera. You might have probably heard. Cloudera is the first company which created a commercial distribution for Hadoop and related tools. So today you can go to Cloudera and ask them to give you Hadoop. What is the advantage? You will be getting the same Hadoop, almost similar what you find in Apache website. But if you install it and if something is not working, they will fix it. You have a support. Since you are paying money, you get support, just like a vendor, right? So one of the companies which is very popular in the world of big data is Cloudera. So they sell Hadoop, Spark, everything as a bundle. Okay, even your lab actually has Cloudera distribution. The lab we are going to use actually runs a Cloudera distribution, and I can also use the this thing, right? If internet is there, because I just want to show you this. So if you just go here and simply type, not now, probably you can do it later. Simply type Cloudera. You can see Cloudera's website, right? And Cloudera came in 2008. So today, if you are buying any big data platform, the leading vendor is Cloudera. So they will give you everything packaged in one product. Like Hadoop will be there, NoSQL, HBase will be there, other related tools will be there, data science tools will be there. So commercially, they are actually the number one provider, Cloudera, right? And somewhere in 2012, we will discuss Hadoop in depth, okay? I'm just giving you some idea. We'll discuss the architecture and all. There is also one more company called Hortonworks. Hortonworks came in somewhere in 2012, okay? And Hortonworks is also the next major competitor to Cloudera. The major difference is that Hortonworks sells original Hadoop, Apache Hadoop. They don't modify it. Cloudera sells a modified version, which they say it is better.
So, didn't they have any legal issues like the technology was with Apache and other companies?
No. So it is actually Apache open source license. So what Apache says is that anybody can modify it and sell it. Only thing, they should also provide a free version, and they do it. So if you go to Cloudera, you can download the Cloudera's product for free. You don't have to pay any money, but you will not get support. So what people do, they will buy only with support, right? So if I want to sell Hadoop, I can start a company, I can download from Apache, modify the source code, I can sell it to you guys. But two things: one, I should give a free offer also, no support. Second thing, that is the story with every open source, right? You have Ubuntu Linux, you have Red Hat Linux. What is the difference? Red Hat.
Utility sale license 2.0 requires them to give open source as well as enterprise.
Yes, not open source, whatever their product, because Hortonworks is open source, Hadoop, and you can download from their product. Cloudera's is not 100% open source, it's a custom product, but you can download it for free from their website and install it on as many machines as you want, but you will not get technical support. So ideally people will not do it, right? Because you need technical support, so you will pay money and get it actually, right? But these are the companies, the Hortonworks and Cloudera as the leading vendors in the big data world. They also provide certification. So if you want to write a certification exam, probably after the Spark class you can try that. Cloudera provides certification exams in the big data world. You can write it and get. There is also one more company called MapR. Three are there. There are many companies actually. The most common ones are three. There is also somebody called MapR. Apache doesn't do it, right? It's open source community. It's not a company. It is like you and me. So I can edit for free, you can also edit for free, but you will not. So if something crashes, what you do? You post a question in the community. Hey, yesterday my old servers were crashed. I am fired from the company. Please help me to fix it. And you don't want to do it in an enterprise world, right? So the real thing is support. To be very fair with you, why still people are trusting all these companies, Microsoft or Apple or Oracle? They get support, right? Something doesn't work, you cannot be able to fix, right? You have to call them and make them fix. So MapR is the third company, which is sort of like popular. This company, if my information is correct, was created by a couple of people who quit Cloudera and Hortonworks, Indians only, right? And they found this company called MapR. MapR is very popular these days actually, no? A very, very popular vendor. The highest paid edition is also MapR, cost wise. They are bigger than Cloudera and Hortonworks. Cloudera and Hortonworks license is cheaper than MapR. MapR's license cost is very high actually. MapR's architecture is also very different, not like traditional Hadoop architecture, right? So for that reason, like I went to GE, I went to Flipkart, they are all using either Hortonworks or Cloudera. They don't use MapR much.
This is also using open source first from them.
They also downloaded the open source Hadoop, modified it and selling it. Same story, but they made a lot of change to the architecture of Hadoop actually. Apart from this, IBM has their own flavor. It's called Big Insights. Microsoft has their own flavor. That's called HD Insight. HD Insight is there. Amazon has. Every company has an edition of their own Hadoop and big data platform. But most popular ones are Cloudera, Hortonworks and MapR. These guys are the most popular ones actually. So
Difference between these three, platforms, like the one which is provided by MapR and Cloudera, because this one is expensive.
So for a developer, there is not much difference. For example, if you are writing a MapReduce program, it will run the same way on all three platforms. There is not much of a difference. The difference actually is that Hortonworks is totally open source. They sell the same what Apache gives. Cloudera modifies it a bit, and they say that with the modification, Hadoop is more stable. That is their claim. We don't know. It's all marketing gimmick. It is same like buying an Android, Samsung mobile phone and HTC mobile phone. What is the difference? End of the day, internally it is Android, but Samsung will say that our Android is better, more bug free or something. HTC will say that this phone will never hang. So only HTC or Samsung know what they have done inside the phone. But end of the day, if I download, let's say WhatsApp, it will run on both the phones, right? Because it is Android. So same thing only. It's just a commercial distribution. Same story with Linux. You can buy from Red Hat. There is also one more provider, right? SUSE. Red Hat Linux, SUSE Linux. Internally, everything is same. If I type an ls command, it will work both ways. Kernel might be slightly different, but end of the day, they are paying open source original Linux only. So same story here, but considering the platforms, Cloudera seems to be more popular, okay, because they got a head start. 2008 they started, right? Long back they started. Hortonworks is also gaining a lot of popularity these days. I have been seeing that. So we are using Cloudera. In our lab, we have a Cloudera distribution. Okay, so but we have not talked about Hadoop, right? So we have been talking a lot about the company, but when did we start the session? I didn't check. 2:30. So when do you have breaks and all? I think 3:30, right? Now, see, I don't have any control on that. Breaks are controlled by her, right? I don't have any control. She has to approve. I don't have any control. Trust me. See, she is talking about schedules and all. I don't know any of this. Okay, I can teach. I can stop. You say stop, I'll stop. Okay. By the way, if you don't like my class, you can walk out also. But you will not do it because you paid money, right? If it was a free class, half of them could have walked out. But since you paid money, you will stay. I know that. Okay. Huh? Yeah, sure. Please ask as many questions as you want.
Because nowadays we could see like Spark is having momentum.
Yes, correct.
Are companies using MapReduce? Are there any opportunities?
No,
in MapReduce?
no. MapReduce nobody is using.
Even the positions also not there.
In the enterprise, MapReduce is gone. Only Spark is there. That is what I'm saying. In your curriculum, there is MapReduce. And why you are learning MapReduce? Two reasons. One is migration. A lot of companies will already have a lot of MapReduce programs and they want to go to Spark. So if you want to go, you should know what is MapReduce. Second reason, even for learning Spark, the concepts of MapReduce are important. Spark also was built on the basic idea of MapReduce. So how MapReduce works, how the program runs, these basic concepts, if you can understand, that will help you to learn Spark in a better way. That is the reason we are learning Spark, MapReduce actually. In the enterprise, totally gone. There is nothing called MapReduce so far.
Spark is a Java framework under coding.
No, Spark uses Python in your course. That is the reason I am not teaching Spark. So initially, Great Lakes asked me, can you teach Spark? I said yes. And then there was a problem because I teach Spark using Scala. I am a Scala developer. You are learning Spark using Python. Spark can be programmed in 4 languages: Scala, Python, R, and Java. 4 languages are there. And you learn with Python. I'm not a Python guy, so that's the reason I am not teaching Spark. I actually like to teach Spark because most of my trainings these days are on Spark actually. But I know Python also. I can teach, but not immediately. I said we'll pick it up later probably and teach that. Sorry. Scala is similar to Java. No, not like similar to Java 8. If you know Java 8. It's a glorified version of Java. Actually, Java 8 was developed based on Scala. So Scala is another programming language. It's a very nice language actually, but I don't know, people do not really like it. Okay, so like it in the sense it's not as popular as Java, right? Java is very popular, but Scala is not so popular, but it's a very interesting programming language. I use Scala a lot in my programs and trainings and all. Anyway, so any other questions before we go to Hadoop and architecture and all? Not many questions. So if there are no questions, ideally, either people understood everything or they understood nothing, right? So both.
So Hadoop is basically replacement for data warehouse, right?
Yeah, you can consider, but it is not just a data warehouse. That is a difference. So you will see soon what is the difference, because if I am buying a traditional data warehouse, it can do only one thing. It can become a data warehouse. I can't do anything else. Hadoop is not like that. It can become a data warehouse and much more, and we will see that.
So new companies will never go for data warehouse. They'll start with
No, they still, so your architecture is,
new company who just
Ha.
think and then
Ha.
starts saying,
ha.
when they go to data warehouse and migrate, or they directly go with the big platform.
See, now the situation is very complicated actually, because if you are starting a new company and ideally you don't have much money, what do you do? You go to cloud, right? So every solution is offered in the cloud, and typically companies will go for this Hadoop and all are available in cloud also. So they will go for cloud distributions. And so always you cannot say that Hadoop is 100% replacement of data warehouse. Okay, it can work as a data warehouse, but performance considerations are there. So sometimes you might need some reports within milliseconds, second, 2 seconds, which probably Hadoop may not be able to do. Hadoop is a batch processing system. It's not real time. So if I have Teradata or what is that, Exadata, Netizza, these guys are really fast, right? MPP. So what companies do, they keep the hot data there. Probably my company has 100 terabyte data. In that, 2 terabyte data I need every day very fast. I'll keep it in Teradata. 98 terabyte I'll dump it in Hadoop. I need it once in a while, and even if it takes some time, it is fine. Okay. Same story with the cloud. So most of the organizations are now deploying everything over Amazon Web Services. So Amazon offers fully managed Hadoop solutions on the cloud. Like you can go to Amazon, ask it, give me a Hadoop cluster. In 10 minutes, you will have fully functional Hadoop solution. Everything installed, up and running, servers, everything. Automation, right? So there they also give you data warehouses. They have something called, what is their data warehouse? Redshift. There is a solution called Redshift. Redshift is an online cloud-based data warehouse. So Amazon offers Redshift to you if you want hot data to be stored. So like I said, everything cannot be given in one solution. You need cheaper, you need the same speed, everything you have to package in one solution. It may not be possible, right? So like someone was suggesting, right, you can compromise speed either, right, or real-time access, right? So same like that. So Hadoop is a solution most of the people adopt, but not everything can be guaranteed at the same time. Okay, so that takes us to the question, what is Hadoop and why this is so popular, or what is the architecture of Hadoop? It's fairly easy to understand actually, because the idea is very simple. I have a single machine. How much amount of data can I store in a single machine? What do you think? I'll give you a server. How much will you store?
Based on the number of orders.
Based on what?
The capacity of the ordering.
Okay. So, and that is based on what? Yeah, so storage capacity, how do you decide? If I give you a server, how many hard disk or how much space you can dump?
Sorry, can you repeat?
Yeah, so I'll give you a server. How do you decide how many hard disk I can add in that?
Based on operating system that can handle the
Motherboard, right? Motherboard is who decides. So the motherboard will say, I'll support 10 hard disks, you can have 10 hard disks. So the idea is very simple. So people initially thought, I can use one machine. And when that machine was not sufficient, what they did? No. No, distributed computing did not came so early, right?
Big servers are there.
They added disk, they reached this disk. So one machine is over. What do you do? Huh?
archive the data.
No, I don't want to archive. Super computing. No, I want cheaper. I can't sell my house. Now another machine is what I'm going to talk, but in between something came.
Clustering, right?
External storage, NAS and all, right? Network storage. Probably you guys are not much from storage background. There was something called network attached storage, very, very popular. Have you heard about EMC and all? Company called EMC Square. They survived only because of these things. So you have something called network attached storage, NAS box. You can buy a box, install the box anywhere, and you can dump the data there. So the system can dump and process from there. That is called NAS. So that will support more storage actually, but it is not within the machine. When NAS was not enough, came SAN, storage area network. SANs are even popular these days, okay? So a full room full of hard disk, you get a fiber channel connection. So if I can dump all the hard disk there, I can store as much as I want. But the problem is, even if I'm using a SAN, this is my SAN. This gives me unlimited storage. Okay. Problem is, it gives me only storage, no processing. If I want to process the data, can one server process all the data in a SAN? No, not possible, right? So processing cannot happen. Storage can happen in a SAN. And SANs are very costly, clumsy to manage. You need separate people to manage and all. So people got fed up with SAN also. So NAS was there, SAN was there. So, and that is where you started thinking about distributed computing. Distributed computing is not a new idea. It was already there. Okay. So in Hadoop, what we are doing is very, very simple. Rather than one machine, you take a bunch of machines. Okay. So I will say the bunch is just for sake of argument, 4. Okay, so I take 4 machines. 1, 2, 3, 4. These 4 machines are, let's say, Linux machines. To be fair, they can be Windows machines, but the support for Windows is very limited in the open source community. So typically we recommend the boxes to be Unix or Linux. So I take a bunch of boxes, say 4 boxes, 4 servers, right? And I can download and install this Cloudera or Hortonworks, any of their Hadoop on this. While installing, it will ask me which machine is master, which machine is slave. The idea is one machine has to be master, the rest of them can be slaves. So in this architecture, I come up with an idea. 1 guy is master and 3 guys are slaves. Fine. So we have not discussed what is the master doing, what is the slave doing. That's later. Okay. But you install Hadoop in a setup that when there is 1 master and let's say 3 slaves. Right. Now the idea here is that if I want to store anything, okay, Hadoop will help me to store among these 3 boxes. Right. So I can use the storage space of all 3 boxes. So if each of them are having a 2 terabyte hard disk, I will get a total capacity of 6 terabyte in my Hadoop cluster. This is called a Hadoop cluster. A cluster means a group of computers where Hadoop is installed.
The definition of Hadoop, is it program or?
Yeah, so Hadoop is a framework actually. It is not a software. So one confusion people have is that is Hadoop a software? No, it is a platform. Okay, and I will show you the different components we have in the Hadoop platform. So if you install Hadoop, let's say we don't know anything about Hadoop, but let's say we install it in a 4 system setup. While installing, it will ask you to select 1 as master, remaining as slave. So I have 1 master and 3 slaves, right? And what Hadoop can do, it can take the storage space of all these 3 machines and project it as a single 6 terabyte storage box, right? So the beauty of this architecture is that let's say you start dumping the data and the data gets stored here, and let's say your 6 terabyte is over. I can add machines on the fly. From 3 I can expand to 30,000 without shutting down the cluster, meaning your storage problem is solved. You don't have to ever worry about storage in a Hadoop cluster. Hadoop allows you resizing without any downtime. So I can add more machines or I can remove machines, up to me to decide, right? I'll tell you how the data is stored. I will come to. So as of now, we have not discussed storage and processing. I'm just giving you a 10,000 foot overview, like what is happening in a Hadoop cluster. So one of the advantages that you can start with like 3 machines and expand to 30, 300 or 3,000 machines. Yeah.
I have wondered, you say like there is no downtime, as it means when the Hadoop software or framework is running, we can able to remove one of the slaves.
Yes, you can also add. When you have your data here and you are analyzing the data, okay, I can keep on adding machines without shutting down them.
So even though my programs are running with the Hadoop framework,
Yes.
I can able to simultaneously I can add machines or remove.
You can remove, but if you're removing, it will have a problem. For example, if the program is running here, if I remove it, the program might crash because this machine is needed. That is not the idea. If you have one more machine here where nothing is running, I can remove it gracefully, nothing will happen. So you are getting something called scaling out. This architecture is called scaling out, meaning you keep on adding more machines so that you can get unlimited scalability. Now I will tell you how storage happens. I mean, so far I did not discuss how storage happens. Yeah.
Why is it not possible in relational database software?
Which one?
Say SQL server.
This sizing.
Yeah.
It is not possible. SQLs are designed in that fashion. If I want to modify anything, I have to first stop reading and writing from my database. Then only I can alter my table or increase anything or decrease anything. Probably I'll be able to add a machine extra, but it doesn't make any sense in a SQL world actually. And in a SQL world, I cannot come up with a 30,000 server setup. That's impossible. Cost, first of all, scalability. Like I said, the major difference here is that in the SQL world, logical division of data. You cannot physically divide the data. So when you're logically dividing the data, like I said, country India, 2 crore people. And if one machine is taking that, it will have more data, another will have less data. I don't have any way to manage it. Here, that will be handled. I'll show you how that is happening. So this is called a Hadoop cluster. So the technical term for this is a cluster. Cluster is nothing but a group of machines, right? So that is available in a Hadoop cluster. Now, typically, if you go to companies and check with them, like I was with this 24/7, a company called 24/7. They are a call center company, and they run Hadoop clusters for analytics and all. They had a 50 machine cluster, 50 node cluster. Each node has around 256 GB RAM and 10 terabyte storage. So 50 into 10 is what? Sorry, not 10. What am I saying? 100 terabyte storage. So 50 into 100 is what? 5 petabyte of storage they had, and 256 times 50, that is the RAM capacity of the cluster. That is a very minimal Hadoop cluster, cheap Hadoop cluster. So typically you'll have 500 nodes, 1000 nodes Hadoop clusters. Because the amount of data you're storing is in petabytes. 1000 terabyte is 1 petabyte actually. So most of the companies, they will have huge amount of data to dump in this. So the size of the cluster will be in that level actually. And Hadoop is distributed, meaning if you install it, it is not getting installed in one machine, it is installed in all the machines, and the components will talk. So it runs in a cluster, not in a single machine or two machines actually, right? So the basic idea in storage is that you can add more machines and get more storage, right? No. I got your question. What if the master goes down, right? I'll come back to that. Now the slave will be acting only as a slave actually. Yeah, so good question. Another thing is that, let me ask you this question. So I am asking you to build a Hadoop cluster with 50 machines. Take an example, 50 slave machines. That is 50 servers. Do you really think it is a cheaper solution in terms of hardware? Like you buy 50 servers or 500 servers, isn't that really a cheaper solution? What do you think?
These are all commodity machines, right?
Yeah, so let them say. Correct. Now, my point is, if let's say you're buying 500 servers, each server will cost you some money, right? So if I say 500 times that money, right, it is really a huge amount of investment for me. That is the reason we call these machines commodity hardware. What do you mean by commodity hardware? Commodity hardware means any machine without any label. You will never buy a Dell server to build a Hadoop cluster. You will build it with cheap throwaway servers. Right? You are not going to buy a Volvo bus, you are going to buy a TM, what is that? Tamil Nadu. I'm not blaming Tamil Nadu, don't take it regionally, okay? Even Kerala, whatever. You're not going to buy a Volvo bus to accommodate your passengers. You're buying a bus, which can break down at any point in time. See, you want to carry all your citizens. Will you be buying only Volvo buses? No, right? If you look at most of the buses that are here, what is your idea? Citizens need to travel from one point to another point, and the bus should be there. That's all. You are not investing crores in buying Volvo buses everywhere, right? You buy just some bus. Same idea here. In a Hadoop cluster, typical Hadoop cluster, the machines that we use are called commodity hardware. Commodity hardware means assembled servers. So you can get it actually. So you are not actually buying an IBM server, because I was also working as a design architect for one of the Hadoop solution. There we got servers for around 35,000 rupees, 40,000 rupees. 40,000 rupees you cannot buy a server. If it is an IBM server, you will pay 2 lakh, 3 lakh. So this was like somebody will assemble and give you. The only thing it will work, it will crash also. It will definitely crash, 100%. So then you will be thinking, if I am having a 500 node Hadoop cluster, if my slaves are crashing, what is the reliability there? I will answer that question. Just park the question for the time being. No. Server is just a big storage box, right? Storage and processing. Yeah, so server is what? A server is, so this is your desktop, normal desktops, right? So normally you have something called desktop at home and all. Server is something which can serve multiple clients in one way. It is a bigger box with bigger storage and processing. So if I want to buy a server, I have multiple options. One is that I go and tell IBM or Dell, buy me a server. So they will give me a branded server. So they will charge a lot of money. They will also give me support and all, but I have to pay 2 lakh, 3 lakh for a server. So normally when I say server, this is what people buy. But in a Hadoop cluster, you never do that. You buy cheapest servers possible because you can afford to have failures in a Hadoop cluster. I'll show you how failures will be handled in Hadoop cluster. But you are not investing a lot of money on the hardware. That is the idea. Because otherwise the solution is not feasible. If I'm buying 500 IBM servers, I can take the same money and give it to Teradata. So as good as same thing, right? So I don't need support or anything. I just need some normal machines. And Hadoop also does not say what kind of a machine you need. You can even build a Hadoop cluster using desktops if you want. Performance will be less, but it will beautifully work. Or laptops or anything that you want. It doesn't say that, right? So that is the, so I'll keep this diagram because I need this diagram again. That is why I'm not removing it actually. Yeah.
Eventually, it is driven by the business. When I'm starting the business, I will not need a Teradata.
Right, correct.
But I may reach Teradata stage also.
Right. So new businesses might take Hadoop more because after 5 years, I may not buy Teradata, right? If this is a situation, I might buy a Hadoop solution probably. I'll tell you what is the biggest challenge in my experience, in my consulting experience. The biggest challenge is knowledge. See, all the companies want a better solution only, right? No company want to unnecessarily pay money. But one thing is that if it is a Teradata solution, in the market if you go, there are a lot of people who understand data warehousing. Data warehousing is not a new concept. If I go to the market, I can get n number of people who know what is data warehousing and they can easily install a Teradata for me. I just have to pay money. But building a team of Hadoop expertise is not easy. That is why you're sitting here, right? If I go to a company also, if all of them have to understand how Hadoop is working, and Hadoop is not like click, click, install. There are a lot of things you have to configure and tune. So people don't want to spend that much of a risk. So one reason is that the knowledge curve we call, right, the learning curve is a bit high. You can't learn it in a day and say that, okay, I'll implement Hadoop. It's not possible, right? So most of the companies are stuck in this position. I'll tell you a real story since you asked this question. So when I went to one of the companies for training, okay, the company said that we want to learn Hadoop basics. I said, okay, no big deal. I'll teach you Hadoop basics. I went to the company. I started the training. They started asking me like a name node, block size, which are all related to Hadoop. I said, hey, I'm teaching you Hadoop basics. You're asking me all these questions. They said, we already know Hadoop. Then why am I here? They said their company got a project related to Hadoop. They implemented Hadoop. They're working on Hadoop for 2 years. Okay, they learned everything on their own. Now they want some training to clarify everything is correct. No, it's actually something really happening. You check with any of your friends who are in any company who are working in big data, they will tell the same story. Because the manager will say, okay, tomorrow your big data project will start. Those who are here can join. Half of them will run away. Okay, half of them will stay. Okay, and these guys have to learn on their own. I am able to share this experience because I go to many companies and most of them are self-learners. There are no resources or training programs like this to learn. They will sit and learn on their own and then learn over a period of time. So that is another problem because if I want to learn Oracle, I can get official trainings a lot. And I have a lot of people who know Oracle. They can teach me, right? So the learning curve actually makes a problem in these cases actually. So I think you guys are better because you will know all this, right? If you are joining in a company, you can say that, hey, I am aware of all these things. Probably you can get an immediate project. Anyway, you are learning to get a job, I believe, right? End of the day, your idea is to get a job, right? I'll show you. I'll show you the architecture. So now what you need to understand. So since we were looking at the high level definitions only, let's dive a bit deeper. Hadoop has 3 major components. There is something called HDFS. There is something called yarn. I can share the slides and PDF. If you want, you can make a note. That's all. It's not mandatory. Third is called MapReduce. So when you download and install Hadoop, only Hadoop, these 3 things will come by default. HDFS, yarn and MapReduce. These 3 components will be installed by default. And you don't have to do anything. They will get installed, right? In this guy is the storage. This guy is handling storage. Okay? This guy is resource management. This is the resource manager. This is processing. The pen is not writing. So HDFS is the guy who is responsible for storage.
You need to say that this is a software piece that manages the storage.
Inside. So if you're installing Hadoop, it will have three components actually. You can see them actually. HDFS you can click and see. I'll show you. Okay. So HDFS stands for Hadoop Distributed File System. It's a file system actually. It is called Hadoop Distributed File System. I'll write it here probably. Hadoop Distributed File System. That is HDFS. Now from your course point of view, HDFS is important because this talks like how the data is stored. Yarn is not that much important, but we will cover yarn. MapReduce we will learn for sure. So MapReduce I'm pushing for tomorrow. So the processing part we will do tomorrow. We are not going to learn how to process the data today. Okay, because if I teach everything also, end of the day you have to go back and recollect all these things, right? You will not get it. So this part I'll push for tomorrow. And how many of you are from Java background? Oh, some of us are here at least. Okay. So because MapReduce is actually in Java. Okay. So we will look at the code, and many people are not from the Java background also. So, and like I said, in the industry, it will never happen that you have to write a MapReduce code because MapReduce is gone from the industry. Migrations only happen. So even if you are able to understand the logic, that's more than sufficient actually. So first, let's look at this guy called HDFS, right? What HDFS is doing. So I will probably push yarn and MapReduce for tomorrow because once I complete HDFS, I just want to show you something called Hadoop ecosystem, okay, which I have to draw here. So we'll complete HDFS storage part. Yarn is a simple piece. MapReduce anyway tomorrow we'll be covering, right? So this is the guy who is handling the storage, and a lot of you are asking how do you store the data in Hadoop, right? Okay. Is this pen? This is gone actually. We have extra pen. This is not writing actually. This one. These are used pens, I think. Also, is it red and green? You'll get black. This is okay, I think, right? Yeah. So let's take a hypothetical situation where you have installed Hadoop in one master, okay? And in my example, we have 6 slave machines. Now, this picture will pose a lot of questions usually, okay? And that's okay. So there is one master and 6 slave machines, and we are talking only about storage, no processing. The master will have a process called name node. The master machine will be running a process called a name node. When you install, it will start running this process called name node. Okay. The slaves will be running a process called data node. Data node. So I'll call it as data node 1, 2, 3, 4, 5 and 6. So technically we will say that there is one name node and 6 data nodes. I mean, that is how you say in a Hadoop cluster, right? So name node is the storage master and data node is the storage slave. Okay, so thus far we have understood. Now, the next thing is that let's say you want to store a file in a Hadoop cluster. Hadoop does not care what you are storing. Meaning you can store any format. Can be XML, JSON, images, video. Hadoop doesn't really care what format of data you are storing. While processing, you have to make sense of the data. So that is in MapReduce. If I stored a text file, I have to write it in MapReduce that read this text file and do whatever I want to do. Okay, the HDFS file system does not really bother about what type of data you are storing. Second point, And probably the most important point is that once you store any file, you cannot edit it. Modifications are not possible. You store it, delete it, that's it. In HDFS, modification is impossible. And now you have to understand these facts really well, because you get confused later, right? So how will I edit? It is not possible in HDFS as it is. So why, you may be asking why it is not possible? Because HDFS is designed as a file system for handling huge amount of data, terabytes and petabytes amount of data, right? And if I want to modify or edit, row by row, like in a transaction that is happening, it is not possible, because if you look at a hard disk, right, there is something called seek time. If a hard disk want to fetch a record, there is something called seek time, right? And if I'm having 1 terabyte file, I want to edit the 100th line, it's not possible for my hard disk to seek and get the data in that. Because you're using all commodity machines here. They are not even faster. I'm not using solid state drives or anything. Very commodity level hardware I'm using here. So Hadoop's idea is that you want to read files sequentially. There is no random access. There is only sequential access. So if I store a file, I can read the entire file and process it. I cannot say needle in a haystack problem. Needle in a haystack problem, meaning if you have a 1 million row table, you cannot say take the 100th line and edit. Not possible in Hadoop, at least in Hadoop. It is impossible. So either you can read the whole data and process it, that's all you can do. And the result can be stored, obviously. If you process the data, you get some result that can be stored. But on the file system, editing is not possible. You can't edit.
You mean to say when HDFS is concerned alone, editing is
not possible. So but directly update is not possible. I cannot open a file and update, say. That is, appending is possible. Appending is always possible. I have a file, I want to append the data, that's okay, because you are just adding in the end. But I'm just reading the 100th row and edit, that is not possible. Now you may be wondering, what if I want to do it? There is a solution. You can do it. You have MPP engines on top of Hadoop which can do it. I'll show you how to do it. I mean, it is possible, but considering only HDFS, ideally if you're storing a file and you got some modifications in the file, you delete it and restore the file. Meaning you don't edit it actually, right?
Can we take the whole file itself?
Can we take the?
Can we take the whole file itself?
Yeah, you can delete. You can delete the whole file. Delete is possible. I am saying that minute edits are not possible, because Hadoop is considered to be a system where you are doing analysis of the data. It is not transactional system. Where will your minute edits and all come? OLTP systems. If I'm having an RDBMS, I want to do insert, update. It's not an RDBMS, right? If you are an RDBMS world, it is possible. I don't have any objection. But here it is not possible by default.
Those days, storage is costly. They needed an update.
Exactly.
Storage is
Not costly, exactly.
So update is then
Correct. And also, we are not doing any transactional, it's not a real-time transactional DB, right? So I don't want to minutely edit also. But worst case, if I want to do it, it is possible. So we have MPP engines on Hadoop which can do it actually.
one more thing, right? If at all if you want to read one particular record, from the start we read it.
Exactly. So if I'm storing a 1 TB file, if I want to process the file, probably I want to process only the 100th line. I have to load the 1 TB into RAM with HDFS alone. So then the business use cases will come. So that is where you need to make a decision. I will train you on that. Meaning, if I'm writing a group by query or an aggregate query, right? Probably I need the whole data. I have a very big table. I'm writing an aggregate query, right? Which will say group by and order and something like that. It makes sense I load the full file because I don't know where is the data. Whole data need to be scanned probably. But if I'm doing a select something where name equal to something, name equal to Raghuraman, only one line need to be processed. For processing only one line, why should I load the whole data? Not required. For that, you have an option. That's called MPP engine. I will show you how to do that. Massive parallel processing engines on Hadoop. So you have tools like Hawk, LLAP, Impala. So there are some guys who can do that actually, and I will show you how they work on that. No. They are dumping in data warehouse, right? From there, they don't want to update. Transaction data update happens here, right? This is where the transactions are happening. Correct. So this is where customers are placing their order, and this data you don't want to change. This data was created by customer. I just want to get the data, right? Probably I want to modify and get it. So once it is here, I don't want to make any changes. I just want to analyze the data. We will see that anyway. Now let's take a hypothetical situation.
One more last question, like name node has not stored any of the data.
No, I'll tell you what is the role. Okay, so what is going to happen? Let's say that you want to store a file. I got a new marker, by the way, right? So let's say you want to store a file of size, I don't know, 192 MB. You have a file, text file, imagine, and you want to store it. The size of the file is, we'll take a break at 4:30. Okay, it's 4:10 actually. So probably we'll take it 4:30 anyway. So the file size is 192 megabytes. You want to store it in a Hadoop cluster. Now, there are a lot of things which actually matters to your real-time experience. Here we are just learning the basics, because in a real company, if you want to connect with a Hadoop cluster, the Hadoop cluster will be somewhere else. So if you are sitting here, okay, the Hadoop cluster will be separate, you will be separate, right? So you will get something called a Hadoop client package. Okay, so one way is that you get something called a Hadoop client. Using that, you can access from your laptop. Second is that you can log into a node. There is something called a gateway machine. This is called gateway machine. So if I am sitting here, this is me, very nice, right? So I can just connect to this machine. From this machine, I can connect to the Hadoop cluster. You don't directly get inside the Hadoop cluster. That's my point, for security reasons and many other reasons. So companies do two things. Either they will install something called a Hadoop client. Even that is very rare. What we used to do, there will be a Linux machine called gateway node. You will get a username and password. You type it, you connect to this machine. This machine will already know how to reach here. You don't have to worry. You issue the commands here, it will run here. Got it, right? But whatever way. So let's say you want to push this 192 MB file from your machine. You connect it to the gateway machine. You said, okay, upload the data. What is going to happen is that, first thing which is going to happen is that your name node machine, this is the master. This guy will tell you something called block size. There is something called block size. This block size can be configured for every Hadoop cluster when you are installing Hadoop. So I am assuming that the block size for this cluster is 64 megabytes. So what is block size? Block size will tell you what is the maximum size of data that you can store. Meaning, if you are storing a 192 MB file, what will happen? It will divide that into 3 blocks. Same thing happens on your laptop. If you are storing a song on your laptop, what happens? Will the song get stored as it is? What do you think? Okay, you store a song, MP3 song, right, on your laptop. What do you think? The hard disk will actually take the song as it is, or it will divide it? It will divide it. It will not store as it is. I think Linux uses 4 kilobyte of 4 KB block size. Linux, Windows also uses similar. Any file system will chop your data and store. Same thing happens in Hadoop also. So I am assuming that this Hadoop cluster has a block size of 64 MB. So this name node will get back to your client package and say that divide your file into 3 or whatever you want, because the block size is 64 MB. So what is going to happen? This file will get divided into 3 blocks. You don't have to do this. This will happen behind the scenes. Like, you don't have to say that what is your block size. It will happen automatically.
Who will do that?
Hadoop client package.
But in this case, gateway.
This gateway has Hadoop client installed. That is what. So this Hadoop client on the gateway will already communicate with name node. Name node will say that, boss, in my cluster, the block size is 64 MB. You manage yourself. So the client will divide your data into blocks of 64, 64, 64. Total is 128. So now you have 3 blocks, B1, B2 and B3. You have 3 blocks now of the data, right? And then again you go back to the name node. you ask the name node, I have 3 blocks, okay, now tell me where to store. And the name node, what it does, it has communication with all the data nodes. It knows where, how much space is available. It will tell you that do one thing, store the first block probably here, just an example. Store the second block probably here, B2. Store the third block here, B3. Most of the cases, the name node will give you different machines. It will never allow you to store everything in one machine. So you divide and distribute. That is how you're storing the data. So now your data is divided into 3 blocks and they are stored in 3 different data nodes. So this is like 6. In reality, you have 500 machines. So 3 blocks is easy, right? But sometimes a couple of blocks may end up in one machine also, depends on the storage. But ideally, it gets stored like this. Now you may be wondering why the block sizes. It's not random. It has, name node has an idea like how much storage space is available on each data node. So it will come up with the free machines. Okay, within that, it just picks randomly 3 of them and say that you dump it there.
What is the need to do that? It can store 3 blocks in same machine?
Yes, that has to do with processing, and I will tell you. So if you think logically, now if I want to process this data, okay, 3 machines can process this data, right? If I store all the 3 blocks on one machine has to process 3 blocks, right? That makes a difference, right? So ideally, you divide and distribute the data. Most of the cases. You don't have to do it, name node will do it for you automatically. This is all inside a LAN. This is all inside a LAN. All these machines are communicating with each other. The data nodes all send a heartbeat to the name node saying that they are alive also, so that the name node can detect how many of them are alive or down or anything. But yeah, so but now we have a problem. What is the problem? If this machine crashes, because this is our BMTC bus, right? It's not a Volvo bus, right? And it can crash at any point in time. If this crashes, my block 1 is gone. I can't get my data. So by default in Hadoop, there is a replication of 3, which means each block gets replicated 3 times to other machines. I'll just draw this, then come to your questions. Give me a moment. B2, again B2, and I'm just drawing randomly. I mean, just taking that these are the machines. B3, probably from here. B3. So if you look at each block is replicated 3 times to different machines. So now let's say this machine crashes. This B2 is still available here and here. I can recover it from here. And now what happens is that the name node will store the metadata. Meaning the name node will write here, there is a file called abc.txt. It is divided into 3 blocks. Block 1 is available on where? 3. Where is it? 3, 2, 6. So B1, 3, 2, 6. B2 where? Where is B2?
4, 5,
1. B3?
2, 5, 6.
Yeah. So this is your metadata. Meaning, if tomorrow you want to read the file, you have no clue where is the file. You just go to the name node, not you. The Hadoop client will connect with the name node, and the name node will pass this information. You go to B1, B2, B3. Sorry, you go to data node 3, 4, 2. You will get it. If any of them are down, it will give the alternative one. So the purpose of your name node is to actually store the metadata or the index. And if the name node crashes, you cannot access the cluster. That is for sure. Because if the name node is gone, then everything will be gone. To prevent that, in most of the Hadoop clusters, you will have an active name node and a standby name node. Meaning, there will be 2 name nodes. These 2 guys will be in constant communication. So if the active name node crashes, the standby will take over. I will talk a little bit more about this later, how this active standby is working. But you don't have to worry. If the active name node crashes, standby will immediately take over. So now coming to the questions. Yeah, please. Correct. Now 3 blocks are there. The replication. 3. Sorry, repeat it.
So it replicates 3 times, right? So is there a possibility that all the nodes which has the replicated blocks?
Very rare. All the 3 nodes going down at the same time is very, very rare. Even though we say commodity, they are not really commodity these days. I mean, even though we say that Hadoop, because the storage and server cost is very cheap these days. So all the 3 machines at the same time going down is very, very rare. But what is the other possibility? King Jong fired a missile, right? From North Korea. What will you do?
Nobody will be there to run the query.
Exactly. Nobody will be there, but let's say King Jong fired only to Chennai, okay? And so in Chennai, the Hadoop cluster is gone, right? So what you do? You are not there to run the query, but the company should survive, right? Disaster recovery will be there. So typically we set up a DR, disaster recovery, and the disaster recovery, to set up that, there is a company called Van Disco, dance. Van Disco, very interesting company. So Van Disco is one of the popular companies who set up disaster recovery for Hadoop. But you don't do disaster recovery like in traditional systems. Meaning, if I have a 100 node Hadoop cluster, I won't set up a 100 node backup cluster, right? That is waste of money. Very rare King Jong will fire a missile, right? If he fires, God saves, right? So what I will do, even in the Hadoop cluster, you have to classify the data. You are storing 100 terabyte data. Probably not all 100 terabyte is so important, right? Is it? No, a lot of data is like archival and all. So in the 100 terabyte data, I will identify probably 10 terabyte, which is very critical. And I can periodically back up that data to my DR center. I don't set up a 100 node cluster in Noida to back up a cluster from here. So we use a tool called distributed copy, distcp in Hadoop, that can synchronize these 2 clusters, primary backup. Distcp, it's called distributed copy. I'm not lying, so some people say I'm making up stories. I'll show you. Yeah, so very excellent question. I'll just come to that. Just give me a moment. So go to Van Disco. Very interesting company, right? I like the name. Who named the company? I don't know. Van Disco. So Van Disco is not only a Hadoop company, by the way. They provide replication solutions. Solutions, backup, disaster recovery. If I go to disaster recovery, why your internet is very, very slow, right? See, it is not even opening up the page. Yeah, disaster recovery. 100% Hadoop availability, right? See, this is what I'm talking about. We used Van Disco in one of our projects. That is why I know. Usually people do not be aware of these things. So I was working as a Hadoop administrator also for some time. That is why I know this, because these are all like real-time things. Okay.
I have a question. Like you
Sure.
said about the command, right?
Sorry. Distcp is the tool.
Yeah, tool. Then why I want to rely on the third party just for this disaster? I know like what is my data.
Yeah, it is same thing. Yeah, but managing this on your own is very difficult actually. Distcp can be run, I know that, even Cloudera and Hortonworks supports, but there are a lot of things you have to consider in running Distcp. First of all, resource utilization will be a problem because you keep on reading and writing the data. Second, if it fails, you don't know how to manage. Distcp can fail at many point in time. So if you are implementing Van Disco, they use Distcp only again, but they have their own ways to handle it actually. I mean, they will ensure the replication happens properly. You don't have to bother about it. Now, I am not suggesting that you must use it or something. If you want Distcp, you can do it on your own. Even Cloudera provides their own some tool for disaster recovery for Hadoop actually. But we are here, right? So my question, why the block size is 64 MB, not 4 KB? Block size can be 4 KB, right? Maybe, I don't know. I'm just asking questions. Seek time. If I'm storing in 4 KB, I can't read. How do you read 1 TB? You want to? Exactly. Now, this I showed you because my math is very weak. 64 times 3 is 198. I know that. That is why I showed this example. In real production cluster, the block size is 128 MB, not 64. I don't know what is 3 times 128 MB, to be honest. Okay, so real production cluster block size is 128 MB. It is configurable. They use 64 also. There is a parameter I'll show you where you can change block size. Okay, Hadoop, the default block size is 128 MB. You should also know, also understand one more thing. There are 3 major releases of Hadoop. Hadoop 1, 2, 3. Hadoop 1 is the older release and nobody is using it these days. So you don't have to worry about Hadoop 1. It is not available in production right now. 2013 was the last year when this was used. So no longer used. Hadoop 2 is what you are using, I am using, we are using. This is the current edition. Hadoop 3 released in 2017, December 15, like 3 months back. Okay. Now let me ask you a question. If you are storing 100 terabyte data in a Hadoop cluster, how much storage you need?
300.
Is that true?
No, it can be more than 300. We need to add the software also running, right?
But only replication considering 300, right? Into 3. Is it good or bad? Bad. What is your thoughts? I mean, see, trainings are always interaction, right? I might know a lot of things, I might not know a lot of things you know, right? So you can, so what is your thought on that?
Fault tolerance can be achieved, right? It's good.
2 can be fine.
2 can be fine. I don't know, I'm just asking. I mean, it's not a yes or no question. I'm just asking, what do you think?
Storage are really cheaper. So
It depends on how much you are about to lose the data.
Hmm.
They will have free.
So there are multiple approaches. One thing is that some companies, this replication factor can be changed, by the way. It's not hard coded. Some companies say 2, right? So you get 2 copy of data. Also, while copying the data, you can mention the replication factor. Very interesting thing. I am copying a file, 1 TB file. This file I can afford to lose. I can say copy with replication 1. But it had led into a debate in the Hadoop world. So a lot of people said that this is very bad actually, because 3 times replication means you are losing a lot of space. That is why in Hadoop 3 there is no replication. Very interesting point. I was just beta testing Hadoop 3, even I don't know completely. In Hadoop 3 we use a technique called erasure encoding. It is similar to RAID, RAID 10, parity. How many of you are aware of it? Parity based RAID. Okay, there is something called RAID, not the Akshay Kumar movie, something better. Okay, redundant array of independent disks. That's called RAID. RAID is a fault tolerance technique. Okay, so based on RAID, they have formulated a new strategy in Hadoop 3 where you don't replicate the data. There is another technique called erasure encoding. If you enable that, you can still recover the data if it fails. They say it will use only 30% of additional storage. Meaning, if you are storing 100 GB, you need 130 GB. Better, right? Much, much better. You don't need 300 GB. But Hadoop 3 will not make it to production very soon. So don't worry, right? Still we are on Hadoop 2. Who needs tea break? Yeah, tea break. So you want the question or you want the break?
We'll finish this question and
Huh?
we'll finish the questions and we'll add anything.
Oh, so you guys are too interested actually. I thought you will all sleep in the class. We should get the Hadoop class in the morning and the other class in the evening, right? No, don't do that. Why?
It should be reversed.
Why?
That is more theoretical.
Statistics is good. I actually wanted to learn statistics. It's good, right? I can probably come and sit in the morning probably. Now statistics, if it is now afternoon, you will definitely sleep. 100% guaranteed. I'm not blaming the trainer, okay? Don't take it that way. Statistics itself is a subject which is a bit boring actually, right? Today. No, tomorrow again second half I am coming.
no, I'm talking about last week statistics was second half.
Is it? So first half what you learned? R programming. Oh, okay. You got it.
And I have one fundamental question.
Huh.
When it is a text file, I can understand we split the files into 3 different
And dump it.
We can read it individually. Okay, it gives some meaning.
Yeah.
What if it has some other file? Let's assuming it, I do not know whether it makes sense. Picture file. The bigger picture file.
I will give you a solution. So the processing has to be handled by the framework. So we have something called MapReduce. In MapReduce, you have a Java class. There is an abstract class in Java I mean, so for those who do not know Java, there is a class, there is a technique where you tell what type of a file you are dealing with, and there are only limited types. You can read text, XML, sequence file, key value. So some limited number of types of files are there. And how do you? So this is a very good question. How do you handle unstructured data? So it is also a very confusing concept. Many people believe that in the world of big data, you are always playing with videos and images. Actually, no. See, many people believe every day you'll go to office and run some facial recognition like you see in the Mission Impossible movie, and yes, I got big data. No, you don't do that actually. You can analyze images and videos. There is no doubt. It's very difficult actually to do. Analyzing video and image data is very difficult because you can't directly analyze it. You have to convert it into binary. Once it becomes binary, in Hadoop you have a format called sequence file. You have to read it as sequence file and write a program to analyze it. It's actually a very difficult job to analyze these kind of files, and not everybody need to analyze it. Let me give you a real-time example. I was working with 24/7, right, the customer care company. What is their primary business? Customer care. In customer care, people call, right? Do you think they will listen to what customer is calling? Yes or no? So you are running a customer care company, not your company. You are giving support to other companies, and you are running a call center. In a call center, customers will call, right? Do you actually listen to what they are talking? Let's say take IDEA for example. How many calls IDEA will be getting in customer care? Do you really think they analyze your calls? Two things. One, it is legally not possible, I think. I'm not 100% sure. Maybe it is possible.
But they say that now we'll be calling it, your call may be recorded for
Fine.
blah blah purpose.
Fine. That is just for the quality, accent and all. That is not doing big data analytics. For example, if you were an angry customer, you spoke for 1 hour, that call is recorded. The person who took the call will go to the manager, and the next meeting, manager will analyze that call and say that this was your mistakes. I am saying, do you actually analyze big data analytics on these kind of things? Not really, right? You will analyze the metadata, not the actual data. How many people called? What was the duration? What they pressed? This is the data, not the actual audio data. Because you can do it. I am not saying it is impossible, but then you have to. So how do you understand what he is speaking? You need voice recognition, right? And it may fail, it may not fail. You are not 100% sure. If it is a US customer or something, we can approximately match. If it's an Indian customer, how do you identify all this? It's not possible, right? He may speak any language, any accent, right? So practically these things are not possible. I am saying you can analyze unstructured data. There is no doubt about it. And companies like Facebook and all do. Facebook actually analyze video data. They have to, for some reasons that they have to do, right? And there they have written complicated algorithms to read and convert to binary and all. But if you are going to work in a regular project, you will all see structured data, CSV files, JSON data, normal text data. But if you are storing also, so you need a class to read this type of files. That's what the question was, right? Yeah, sorry.
This replication factor, suppose one data node goes down, do Hadoop framework again replicate that one?
That's an excellent question. I also missed another question from this side. That was the same question? No. Yeah. So I think we'll take a break because I need more time to explain anyway. When I say Hadoop, it is this. We know there is HDFS, Yarn or MapReduce. But that is not only Hadoop. You have a lot of other tools on top of that. So you need to have at least a rough idea as to what are the tools we have in the Hadoop ecosystem, the whole stack, right? So I will talk about it. Once we complete HDFS discussion, I will go to the ecosystem stack, because in the ecosystem stack, you will have a lot of questions. How this works, how that, at least a basic idea, because I'll take the same ICICI scenario and I'll tell you how we moved. Then you will get a better idea probably, right? Yeah, so we were on this question side. Yeah.
Yeah, sorry, I've been raising my hand for quite a long time.
I'm sorry, I didn't notice you.
See, question is, like on the data nodes, say like one of the nodes gets failed and you plug in a replacement node. Okay, and will Hadoop automatically lost data from the remaining nodes, how would that
that's an excellent question. So the question was that if one machine is totally gone, if I plug an additional machine, will Hadoop automatically take care of copying the data? No. The point is that that's called commissioning. So if you add a new node here, or let's say we are simply adding a new node. Let's say the existing setup is that if I add a new node, this node will be empty. So you have to do something called balancer. There is a utility called balancer. I will run balancer so that Hadoop will analyze and understand that this is underutilized, this is overutilized. It will move some blocks here. If you don't run balancer, it will keep it as a new machine, but the data will not be balanced. So we run something called balancer to manage that. There was another excellent question. This replication, how does it work? So replication, it works in a very interesting way, because if you're writing the data, the first block goes here, B1, right? Now this guy will tell this guy to get a copy. And this guy will get a copy. And then this guy will tell this guy to get a copy. So third copy is got. Finally, this will send an acknowledgement here, and you will get an acknowledgement. Then only a block is written. So it is called pipeline write. You are not pushing everything at the same time. As a pipeline, it writes and gets an acknowledgement. That was one question. Yeah.
acknowledgement to the name node or gateway?
Sorry. Yeah, so this will be communicated when you are doing a Hadoop copy operation. You will talk to the name node, and the name node will give you a list of data nodes, a chain of data nodes which should get the replica, primary and replica. This information will be passed to them.
What is the maximum storage for name?
Maximum storage. Excellent question, because the name node actually stores metadata. This metadata is in the RAM. When the name node is running, the metadata is being served from the RAM actually. It also persists in the hard disk, so that in case it crashes, it gets. For 1 trillion files, 64 GB is the RAM required. So you should actually calculate the RAM size, not the hard disk size. 1 trillion file, a file size can be anything. I'm not talking about file size, because for a single file, 256 KB of metadata is created. One file means how many blocks are there, its replica, that is the metadata, right? So 64 GB can handle 1 trillion files in a Hadoop cluster. So accordingly, you have to increase the RAM size. Hard disk size is fine. You don't need much hard disk size.
What is the typical file metadata size? You said 260
KB per file.
per file.
So once the data or name nodes increases, storage nodes increases, so it means that the number of files are increases.
Exactly.
You will replace it with a new machine from name node?
No. You can increase the RAM of that machine, right? And the name node is not a commodity hardware. Very important point. The name node is a costly machine. You don't want that's a Volvo bus, right? Because you don't want that to crash unnecessarily.
One more thing, right? While this, suppose a particular data copy has been lost due to some reasons, maybe the hardware, does automatically Hadoop framework recreate that copy?
Exactly. So if let's say this machine is down, very good question. If this machine is down, this B3 and B1 is gone. Automatically, it will create one more B3 and B1 somewhere. And if this machine comes back online, it will delete them, because it has to always maintain a copy of 3. Always the replica should be 3, should not be 4 or 2. So that is automatically handled. You don't have to worry. It will delete and recreate if it wants.
In the same line, this suppose while making the replicas, it is taking into consideration data locality, whether data name nodes are near
Yes,
or not.
yes.
It will take into
It will take. Data locality, nearby considerations will be there.
In that case, how the metadata will be updated on the name node?
Okay, so I will come to that in just a moment. Metadata, I have to talk about it. Yeah.
One more thing, the first thing you told, block size is 64 MB.
That was because 128 is actual. Okay.
Let it be whatever MB.
Okay.
As Hadoop, as I understand is, HDFS is an abstract file system. But
On top of
underneath,
Linux.
Underneath the
Huh.
native file system is there.
Correct.
But how come it is going to reduce the sync time? 64 MB is not going to store continuously, right? Suppose a file, I'm storing the file with the full block size. So, what does it typically, what does it states?
So when you are installing HDFS, even though internally it is Linux file system, it will talk to the Linux file system, and the 64 MB will be further chopped down. The 64 MB is on Hadoop. Internally on Linux it is 4 KB. but this entire 64 MB will be one point. It will not fragment it. You are getting my point, right? If I'm simply dumping 64 MB on Linux, it will divide it into 4 KB and fragment it in many places.
It will be continuous in this point.
Here it will be continuous. So read and writes are faster. Any other questions you have? So balancer has to be ideally run by the administrator, Hadoop administrator. You have to manually do it. And there is a command called Hadoop balancer. You can run it. From the GUI also you can run it. I will show you. So tomorrow if you guys can remind me about this, I'll show you all this. I may not be able to run a balancer, but I can show you where it is. I will forget, right? So tomorrow I'll show you the Hadoop cluster. I can show where are these things actually. So the balancer is part of your Hadoop installation. HDFS. So you can say run balancer, but normally we will run balancer only during off-peak hours. Like during the daytime if you run it, it has to move the blocks and your processing and all will get interrupted. Won't interrupted, but it will be slow. So let's say midnight 12 o'clock, I run the balancer. I make sure that the blocks are evenly distributed. So this block size, that is also a very good question. This block size is just a logic, okay. So my question is that if I have a 200 MB file, how many blocks will be there? 2? No, let's take 64 MB and 200 MB file. What will be the size of fourth block?
No, it will take the same size.
So how many of you say that the fourth block is 64 MB? I will say yes. How many of you say fourth block is 12 MB? Not 8 MB, right? Very less. It is 8 MB. It's not 128 MB. The block size is valid only when the file size is more than the block size. Any file you divide, ultimately you will end up in a 10 MB or 8 MB. So Hadoop will keep it as it is. Otherwise, if it is storing in a 128 MB piece, the remaining data is unnecessarily. So it is a logic actually. It is a logical, even though physical division happens here, okay, logically it will keep a block of 12 MB only because you have only 12 MB data left there. Got it? It's not like physically I'm marking a space and filling only this much. That doesn't happen like that.
As you said, the HDFS is going to contact the native file system and
Yeah.
going to have that one registered, right?
When you are storing only it contacts, right? If I'm storing a file of say 200 MB, it knows 4 blocks need to be created. Right. Fourth block size, it will say that 12 MB only I need because I have only 12 MB data.
So this 12 MB also will be a sequence.
Exactly, it will be in sequence only. Otherwise, remaining space is wasted, right? And every file will have some wasted space. So why are you wasting that much space? If I store 1 trillion file, how much will be wasted? Can you think? Lot of file size, right? That is not required actually. So there is a logic internally built in to HDFS that the block size is valid as long as the file size is bigger than the block size. Once you chop and last 10 MB, that is 10 MB only. It's not 128 MB or 64 MB, right? It will increase, exactly. So if you append, that block size will increase. So that's a good question. So in this 200 MB file, if I'm appending the data, right, it will increase. It will provide a room for that actually, because the last block was only 8 MB. Now you keep appending the data, that block will become a 128 MB. It will keep on.
The continuous block will not be available, right? It's something else. The continuous block will not be available. Somebody else will have been taken away.
No, in Linux, what it does is that when it is creating a block, okay, if the block size is small, it will say that give some room. When you are creating the next block, don't keep it immediately next to that. The hard disk is so big that it should not immediately create it there, right? Most of the cases append will happen. Very rarely, probably it may not work there. Very rarely, okay, it is almost impossible. In most of the cases, you will get that data there. Yeah, so that is for processing. I told you I will come back to that. So if I am putting all the file, one big file here, if I want to process it, this machine only can process my file, right? If I am splitting it, now 3 machines can parallelly process my data, right? My processing is faster. So if I am, the same time you will not run all the processing. Another misconcept that people have is that in a Hadoop cluster, If you have 100 TB data, all the 100 developers at the same time will say run. No, it doesn't work like that. Are you getting my point? You have a lot of data in a Hadoop cluster. You wrote a program, I wrote a program, he wrote a program. We won't come to office exactly 10 o'clock and say run the program same time. Doesn't work like that. You may have a lot of data. People would have written programs, but you schedule the program. So that is where scheduling comes. I was about to talk about it. So if you are working in a Hadoop cluster, resources are very important, right? Because each machine has processor, then hard disk and network, right? And each machine will be processing your files, whatever you have written. So we have a tool called Uzi, Apache Uzi. Uzi is a tool actually that comes along with Hadoop when you install as a tool. So in Uzi, you will be scheduling your programs. You wrote a Spark program, analyze 100 TB data. If you immediately submit the program, probably the program will not work because already somebody is analyzing the data. Where do you have space to fit all these things, right? So what you do, you write it in Uzi and you contact your Hadoop admin, say that I want to analyze 100 TB data, when can I run this? He will say tomorrow 11 o'clock. Okay, submit. Most of this analysis is batch, not real time. Real time is a different case, but batch jobs, you schedule it via Uzi. Also, you have something called queue in Hadoop. For example, you are working as a developer. I am a tester. Can we have same access in the cluster? Of course, testing cluster will be different. But let's say I am a researcher. You are a developer. He is a data scientist. Can we have the same access on the Hadoop cluster? No. Probably you are a developer. You need more resources. Okay. Probably I need less resources. So what we do, we create something called queue. Okay. There is something called queue. We create. In those queue, we allocate resources. If you are coming from the developer team, you will get 30% of the resources. If you are coming from other team, you get 40%. Right. Otherwise, I can utilize all the resource, right? If I write a program, I can make the cluster only for mine. That's not possible in a Hadoop cluster. So management is entirely different. How do you run these jobs are all different. But to just answer the question why you are dividing is that you can use parallelism. Otherwise, a single machine has to process everything, right? Quota size is different. Queue, right? Queue means multiple teams will be there. Each team can get a queue. So when you submit a program, you will submit to a queue. You will not directly submit to the cluster. So let's say, just for an example, let me take a
It's queue in terms of processing time when it will be processed.
queuing in terms of resources. Say for example, in your Hadoop cluster, you have
You mean data nodes?
you have 10 data nodes. Each data node has, let's say, 10 GB RAM, right? So total you have 100 GB RAM in the cluster, right? And let's say 10 data nodes, each has 4 core processor. So you get what? 40 core processor, right? Now, if somebody want, they can get all these resources in their program. If he is getting, nobody else can run a program in the cluster. It should not be like that. So what we do, we create 4 queues, let's say, or 2 queues. In this queue, I will say 60% of the resource should be there. Here I'll say 30% should be there. Here I'll say 10% will be there. So this will be the developer queue. They will get 60% of the resources. That means 60 GB RAM and what is that? 60%, right? 24 core processor. So they will never get more than 24. So multiple ways of scheduling is there. In the normal scheduling, they will get maximum 60% only. Or if the other queue is empty, they can claim the resources from there.
So queue is a tool or just a phenomenon?
No, queue is actually a Java class. You can create something called schedulers in Hadoop. There is something called capacity scheduler, fair scheduler and all. So the scheduler is called a queue. So if I am creating something called fair scheduler, within fair scheduler, it will allow me to create queues. So I can say create 3 queues, and whenever somebody is submitting a program, they have to mention the queue name also, otherwise the program will not run.
So, for example, developer team has been provided 60% of the data.
Okay.
Like number 1 to 6.
Okay.
And you want to use, the other team is provided 30%.
Correct.
But the data might be different in different data.
No, this is not talking about the data. Data, they will get their data. I am talking about RAM and processing power.
Okay.
Data is available.
Okay, so the allocation of RAM from different.
So if I am running my program, we will come to MapReduce tomorrow.
This is what will explain the yarn process, right?
So if I am running my program, I need a RAM and processor to run my program, right? How do I run my program? I need RAM and processing power. That the cluster should give me, right? So I can limit people based on queue. Only this much resource you can get. That is possible. That is called scheduling in Hadoop.
And one more thing, when as you told, we are submitting jobs only to the queue.
Huh.
The processing is dependent. It can be first in, first out. It depends upon the scheduler.
So when you submit to a queue, inside the queue you can write a policy. The default policy is FIFO, first in, first out, right? Apart from FIFO, you can also have priorities and other things. You can write your own policy, whatever.
But at a time, in the cluster, only one job is run.
No, at a time 3 jobs can run. These 3 queues people can submit, right?
Okay. 3 queues, 3 jobs at a time.
3 or more than. For example, this queue has, let's say, 60 GB RAM, right?
Yeah.
I need only 20 GB RAM. You can also use 20, right? 3 people. Depending on how much you want to process.
Available.
How much resource you want, that has to be, I'll tell you how to calculate that.
All this, what is important for lab exercise?
None of this is important, but these are all admin activities. None of this I discussed is actually related to your course, but this may all make sense when you start working. See, learning is one thing. Okay, if we just want to learn, we'll just learn MapReduce and run some programs and go home. But when you actually start working, these things are actually used in real life.
Yes, useful. I
Right.
just want to know.
No. Don't worry. Scheduling and all oozy, nothing comes in your lab part. In the lab part, actually what is there? HDFS is there. You will load the data, read the data. MapReduce is there. Hive is there. That's all. None of this actually comes. But I can show you at least from the Cloudera Manager UI this thing. What is that? Balancer. And where is the name node? Where is the data node? These things we can see since just we want to look at it. So are we clear about HDFS? I think at least we can say that on a basic level we are clear. Probably not everything, but yeah. I didn't get records means. So here it is text file or flat file. Any file you can select. So by default, like I said, if you are storing something on HDFS, HDFS does not care what is your format. You store an image, it will store as image, JPG. You have to make sense of it while reading the data. It is not like RDBMS. So that is one thing. It is not like RDBMS at all because HDFS is a file system. So if you dump, say for example, on my Windows machine, can I store an MP3 file? Can I open in Notepad? Why?
You don't know how to parse it.
Exactly. I can store an MP3 file in Hadoop. If I want to process, I should write a logic to process it actually. That is for only queries. MapReduce is not query. MapReduce is programming language. Queries you are talking about Hive. So Hive is your data warehouse on Hadoop. Hive will accept normal SQL queries, whatever SQL. On the data, yeah. So you have to create a table and all from the data. Exactly. So Hive is like your data will be in HDFS. You have to create a table, give a schema, then it looks like an RDBMS table. Then you can run your queries. No, it's not an RDBMS at all. Actually, the data is running line. Exactly. It can be a CSV, it can be a text file, regular files it can save. Yeah. I will show you in Hive how to store and process the data, right? Yes, in Hive you have something called indexing, but it is not as efficient because indexing will really work well if your data can be managed by the RDBMS system or the data warehousing system. If I am indexing the data in Hive, the data is actually managed by HDFS. Right. So I can get some performance improvements, but not like in your RDBMS. Never compare Hadoop with RDBMS. You can, at the most, you can compare with a data warehouse because it is not transactional, right? It's equal to a data warehouse, I can say. I didn't get you. You're asking if I copy a file, can I? No, you don't create a record. That's what I'm saying. You are again talking transactional, right? You don't create a record. See, this is a big data platform. So you dump terabytes of file. You are not creating a record. Very rarely you edit. That's what I'm saying. This needle in a haystack problem, right? So very rarely you say that I want to create a new record. You will be adding files, continuous streams that will be huge in size. You can afford to lose. You can afford to lose the data. I will talk more about that in the ecosystem side. Okay. Ha. So a lot of companies actually run this using virtual machines. It is possible, but performance we cannot always depend on VMs. I mean, VMs are ultimately what? They don't use, if it is a bare metal virtual machine, you can guarantee, so there are two types of VMs, like you have something called bare metal like a Hyper-V and all, there you can get good performance, or VMware. If it is not a bare metal, no, performance will be compromised, because again you have to go through one layer, then talk to the storage and all. Yeah, it can be configured. So I will just talk about something called Hadoop ecosystem, and then we will discuss further.
See, let's say that the client wants to read a file that is Hadoop.
Okay.
And it first checks with the name node. Name node will basically give the metadata on what are the nodes where
Correct.
The file is located.
Correct.
And is there any process that would actually collate the data from all the nodes and provide to the client?
No, it's all a Java call actually. These are all, so the Hadoop is actually written in Java. So client is also in Java. Everything is a Java method actually. So you are just invoking a Java object. There is a fs read object which you call, and this object will get all this metadata and give it to the client. And the client will keep it in memory and then go and read one by one from wherever it wants. Okay. So I will just explain this ecosystem and come back to your questions further. I know there are a lot of questions and it is good, but we should finish a couple of topics more as well, right? So I'm just taking this ICICI use case so you guys will understand better. So traditionally we do something called ETL to bring the data, right? And now what we have this Hadoop. So I'm just writing here HDFS. So this is your HDFS file system. This is HDFS. And in the world of Hadoop, we very rarely do ETL. Why? Because ETL means you are reading the data, transforming the data, and dumping the data. If you are getting big data, transforming it on the fly is very, very difficult actually. So in the world of Hadoop, what we do is something called ELT. Instead of ETL, you will do something called ELT. That is extract, load, and transform. So first thing is extraction. How do you get the data into a Hadoop system? So there are multiple tools. First of all, if you are having structured data, say you have data in Oracle, you have data in MySQL. So this is all structured data which understands SQL. There is a tool called Scoop. There is a tool called Scoop. Scoop can get this data to your HDFS. Scoop. It is an ETL tool. You can't call it as an ETL tool. Scoop is used to bring the data from any SQL system to Hadoop. Transfer the data.
It's an external tool out of
No, it is part of Hadoop ecosystem. So what is going to happen when you say that you want Hadoop from Cloudera? Cloudera will give you Hadoop. On top of that, it will give you all these tools which I will be explaining now. So Scoop is part of your Hadoop ecosystem. And Scoop is used to bring data from SQL stores. It can take from, let's say, Oracle, it can take from MySQL, but it cannot take from flat file, JSON, nothing. Only SQL, only places where SQL understood. So from ICICI use case, we got all the data from CRM through Scoop to Hadoop. Okay, so Scoop is an Apache tool. It is a very lightweight tool. We faced a problem there. I wanted to discuss that. Let me ask you this question. This is ICICI Bank's core banking Oracle database. Do you really think they will allow you to touch it? Then how do you get the data? Meaning? Who will copy?
They should be copying the application.
replication? Any tools or how do you replicate? I mean,
So you can take a dump of the database and then put it to another database and you can.
excellent. CDC, change data capture. So we face the same problem. There is Golden Gate. Oracle has a solution called Golden Gate. So CDC, change data capture, meaning they will not allow you to touch it, right? So they will have some replica solution. So where they will write it into a replica DB, it's actually a log file. From there you have to capture and get it. They won't allow you to directly touch their Oracle DB by any way. It's called CDC, change data capture. No, that will have only the delta. So what they will do, they will give you the original data, backup data they have. The CDC will capture only the changes in the database. Got it? And then you have to, from CDC, you can write a Java code and then get the updates dumped into here. That is how you get it.
You mean to say the original core database is going to have a replica in another instance?
Okay, CDC will discuss later because I need to spend half an hour here to explain. Just understand the changes can be captured because it is anyway not related to your big data platforms. This is just a business scenario.
I mean to say from the core banking system they are going to have a replica in
Yes, of course.
there they are going to give all these
Exactly. So we will not discuss CDC in detail because it will take another half an hour. I don't want to spend half an hour. It is not related to your syllabus anyway. And even I didn't do CDC because there will be teams who will do that. Even I was not aware of it.
It's a technique.
It's a change data capture is a technique. So whatever changes are happening here, it will capture and dump somewhere. From there you can read it.
It is something in the main database.
Database, exactly. From there you can read it. So I was just saying that we use CDC to get the data. So Golden Gate is a product that Oracle uses for CDC. Anyway, we use Scoop to get from here and here, right? Now comes the place where we are having a lot of debate actually, okay. Now the real question is that, okay, I know how to get the data from here through Scoop, right? What about the other data, right? Now, if you want to get the other type of data, there are multiple ways you can get, okay. One of the most popular used tool is called Flume. Apache Flume. Flume is a point-to-point delivery tool. What Flume does, it takes the data from source, give to the destination. The source can be anywhere. And normally Flume is used for unstructured data. Say for example, in a folder, you are getting all the JSON data or XML data or flat files. I can create something called a Flume agent. And this guy will keep on polling that folder. Whenever there is a new data, this guy will read it and it will send it to HDFS. This is what Flume does. Now, the real interesting thing is that Flume can do two things. One thing is that it can simply read all this data. Let's say this is in a folder. Okay? It can simply read this data and say send it to Hadoop. This is fine. But ICICI Bank also had another requirement. So this is simply you're collecting the data and dumping into Hadoop. They don't want to do that. Okay. So they wanted, they had a requirement in which what used to happen was that this Flume was capturing some data. Okay. Some data was getting generated in the form of JSON here. So in the social media, if somebody is clicking on one of their products, they wanted to send an SMS. Real time. So this JSON data will keep on coming. You will keep on getting it. And Flume can directly dump into HDFS. But that is useless for me because I want to analyze the data whenever the data is getting generated. That is where this guy comes into picture, Kafka. So there is a difference between Flume and Kafka. Okay, you have to understand. Flume is like a point-to-point delivery. You give me the data, I will dump it there. That is all Flume does. It doesn't do anything. And Flume does not store the data anywhere. Meaning it will take the data, temporarily it may store and then immediately push the data. Kafka is a message queue. Anybody aware of message queues? So Kafka is your message queue in the big data world. Meaning what this guy will do, this guy will be running in its own cluster. No Hadoop cluster. This guy will run on its own cluster like 30 machine, 40 machine. This guy, Flume can send the data to this guy, Kafka. And Kafka is a cluster, so it can store the data. By default, it can store for 7 days. By default. Okay? Anybody can go to Kafka and get the data. Publish, subscribe system, we call it. The advantage is it will store the data so that multiple people can ask it. Flume is point to point. If Flume gets the data, it dumps the data here.
But here is 2 points.
Yeah.
Right?
So here what we used to do, we didn't do this. Okay. We got the data to Kafka. From Kafka, I can push it to HDFS one way. So I'm getting the original copy here. Okay. Now in ICICI Bank, so the next question is that how do you analyze data in real time? So somebody is clicking on Facebook, the data is coming as XML, right? And immediately when the data comes, Flume will read it, push it to Kafka. So now the data has reached till Kafka, but I want to analyze the data in real time. That is where your Spark comes into picture. There is something called Spark streaming. In Spark you will learn this, I think, I'm not sure. Okay, there is something called Spark streaming. So Spark streaming is a utility which analyzes real-time data. Now Flume can read any type of data. I didn't get, sorry.
As in the
Point to point.
source to and the destination.
Yeah,
just
yeah.
point to the transporter.
So it just takes from here, dump it to Kafka.
Is it possible for Flume to contact the SQL Server database and get the data to?
No. Flume will not work with SQL Server. Only Scoop will work.
These are
Any SQL data, Scoop. Any other type of data, Flume. Now Kafka can also directly get this data. Now this is a bit confusing, I know, okay, because this is very new to you first of all. But Kafka can also directly get the XML file. But the advantage is that Flume is pull based. Pull based means if I install Flume without disturbing this setup, I can pull the data. Kafka cannot pull the data. You have to install a tool here and modify the existing setup. Flume is pull based, meaning if you install Flume here, it can start reading the data automatically. I don't have to modify anything. If I install Kafka directly, Kafka can also get the XML data. It can read the XML data, but I need something called a Kafka producer. That has to be installed here on the ICICI source system. That is not possible, right? So since it is an existing setup, I can't directly get through Kafka. I get through Flume. Flume will give to Kafka. Kafka will send one copy to HDFS because I need to keep the original data. Second copy it will send to something called Spark streaming. Spark streaming is a library available in Spark where it can do real-time processing. The moment you give the data, it will process it real-time. So somebody clicked on that, immediately the data is here. Spark streaming will process it and say send an SMS or you can take an action, whatever you want. Now, what are the other tools which can do real-time? Apart from Spark streaming, you have something called Flink. You have something called Storm. These are all real-time processing tools. You might have to make a note of that. Yeah. Sorry.
Kafka, if I relate it to Facebook,
Ha.
to understand
Ha.
Flume, you can say it's WhatsApp.
Yeah, correct. So Kafka can be Facebook, Flume can be WhatsApp because WhatsApp is point to point, right? One to one, and Facebook is like distributed, right? Anybody. Eh?
If you go and edit it, then they will keep it.
WhatsApp also they will keep it, right? I don't know.
They will push it to you after that. They will not. You cannot go and read it. Once if you are changing.
Oh, okay. That context. Yeah. Correct. Good. I didn't understand that point. See, so that's very easy. So in WhatsApp, it is push, right? Flume is like WhatsApp. Okay. Once Flume gets the data, it will push it to somewhere. It will not store the data. Kafka means it will get the data and store it for you as long as you consume it. So in ICICI Bank, this was the architecture. We got it through Flume, sent it to Kafka. Here one copy will go to Spark streaming. So this guy will do real-time processing and do something. Okay. One copy will go to HDFS. So the data will remain in Kafka as long as you want. You can configure. By default, it is 7 days. You can also mention the size of the data. I want to keep only 10 GB data, 20 GB data. There is something called topics in Kafka where you can mention how long the data should stay here. It's a cluster, right? To store the data.
Why can't Flume send to Spark directly?
It can, but it can do only one. Then it cannot send here, right? You're getting my point. Flume can send here, then this will not happen. It is point-to-point delivery. I need a copy here, I need to send there also at the same time. Also, probably tomorrow, I want to build one more application, okay, which will do something on this data. And that application, I have a new application I build tomorrow, that can also get the data from Kafka. Kafka is like, if you give data to Kafka, anybody can take it from me. I will store it for you. Got it. Flume is like point to point. Got it. Kafka will store it so that anybody can come and get the data. 10 applications can read from Kafka.
Spark stream
Yeah.
take from HDFS.
Sorry?
Why can't Spark streaming take from HDFS?
Slow. It will be very slow, hardest to read. I can directly push in real time, right? So before you get out of Tanik's shop, I want to send an SMS, right? After processing. No, this will be one golden copy will go here. The original Facebook clicks and all golden copy will go here. That tomorrow you can analyze. Now you clicked on a page, insurance page in Facebook. I want to immediately contact you. So it has to be processed and understood, and then some decision has to be taken. So I'm sending one copy here, one copy here. Here the processing will happen. Here simply the original data will be stored.
So there, after the process, data will be deleted, discarded.
It will be discarded because original data is anyway here. You can store it also.
But generally here they will be stored.
Yes, golden copy will be here. It's called golden
The
copy.
map produced with the help of HDFS, the map produced will not give similar.
No. Map reduce cannot do real time. It is batch.
Just only the batch process.
Yeah.
So if we have Flume and Kafka
Huh.
in place, so do we still need Scoop? Because
Yeah, because how do you read from Oracle? How do you read from Oracle? No. Flume and Kafka cannot. Only Scoop can read from SQL based stores. Now, Kafka is a very interesting thing. I teach a 3-day course only for Kafka. 3 days. It's not enough actually to teach Kafka because it's such a big topic actually. Because Kafka can be a message queue. ELK stack, right? No. ELK stack will not come here in this example. We didn't directly use ELK stack. We were using, that's what I was telling in the break to somebody. What we were doing is that we used to store the data in Hadoop. To process, we were using something called Splunk. There is a tool called Splunk. Splunk can actually replace your ELK stack. It does ELK both in one tool. So that is for visualization, right? You have some log files, machine learning, you can just apply and visualize. We were using something called Splunk. So this is the big pipeline I'm talking about. You can also build it using ELK if you want, I'm just saying. ELK is a stack actually, Elasticsearch, Logstash, Kibana. It's a, probably he can explain, right? So who was working on ELK? Somebody was? Yeah, so you can explain probably what is ELK.
That's also like similar to the Hadoop architecture, but only thing it is very lightweight.
Lightweight.
So we can install it in simple Linux server.
But probably not for 100 TB, 1000 TB.
It is for 10 TB, 5 TB, 2 TB also.
So let's say you're getting a lot of log files. You want to make sense out of it, right? From different places. Let's say I'm collecting all the logs from this network. I want to make sense out of it. So I need a tool which can easily collect it, clean it, and then display in a dashboard. That is ELK, what it is doing. There is a tool which is very similar. That's called Splunk. That is not in the big data. In the Hadoop ecosystem, it is not there. That is a third-party tool actually. Open source. Yeah. Exactly.
can we use Flume for SQL and
No. That's what. SQL only Scoop.
does it mean that we cannot do then live processing of the Oracle or this data?
Exactly. So that's a good question. So when Scoop is getting the data, right, Scoop will ideally push only to here, HDFS. Okay. But I can say Scoop to push to Kafka also. That is also possible. Once the data is available in Scoop, okay, I can say give it to Kafka. So either it can be read for live processing, or Scoop can push to something called Hive. We have a Hive here, which is a data warehouse. From there I can analyze in live if I want.
From Hive, Spark and
But normally this transactional data is not much used for real-time processing. You are doing it based on this Facebook clicks and all. Based on this transaction, I can get it. Now, just to answer his question, that's a good question actually. Can you give me a suggestion? So a customer is making a transaction. Using ICICI credit card. He made a transaction for 50,000. I have to immediately send him an offer. So if he is making a transaction here, I made a mistake here. I want to show that. If he made a transaction here, 50,000, okay, where will be the data? In Oracle. How do you capture the data from here? You will say Scoop. We were using Flume because your CDC will be producing a log file. The log will be captured by Flume, not Scoop. So here Scoop will not come into picture. Here scoop will come because I'm directly reading from CRM. My CRM is in MySQL. MySQL is original table and I can read directly. But in the Oracle case, I was not directly reading the table. If I want to read a table scoop, but we were reading the CDC, change data capture, that was a log file. That was being collected by Flume actually. So you can actually make it. So this is the answer. If you want to make real time, okay, you need some CDC system which can push the data to Flume actually.
Go to an example from business side.
Huh.
You might made a purchase of, say, for example, 20,000 or 30,000. Immediately when you log into the credit card transaction history,
Huh.
you give an option like convert it to EMI.
Exactly, exactly.
Nothing but
Real time. I have worked on a banking use case where, so I'm talking about this side, Spark Streaming, Flink, Storm. So Spark Streaming is what you will be learning. Flink and Storm are other frameworks which can do real-time data processing. So you will be wondering why real-time data processing is so critical.
But all these things are same variants, right? All
The,
three streaming.
all three are real-time. You may use any of them. Flink is Apache, Storm is also Apache. Storm is almost out of the market. Okay, Spark Streaming and Flink are popular right now. We have worked on a use case with Citibank. You swipe your credit card, right? How do you know it's a fraud or not? You are swiping your credit card. I want to find out whether it is a fraud transaction or a real transaction. Correct? Huh.
really I'm living in Delhi
Hmm.
and my native is Pondicherry. And the max for the past 1 year I would have traveled, let's say, South India only. Suddenly I made a transaction in Delhi.
Exactly.
That's a problem.
Huh.
What happened to me last
Prevention, not prevention. Even I
No, even you don't have to be a fraud. Let's say I use a credit card regularly. If I one fine day, if I suddenly pay in US dollars or something, I'll get a call from customer care. Did you really make it? That means, imagine say HDFC Bank, how many credit cards will be in circulation and how many people will be transacting every day? Do you think somebody is sitting and monitoring every swipe? Spark Streaming. You are collecting all the data, all the credit card transactions will get dumped, okay? They won't come in a relational form, they will come in some flat file or something. Your Flume will catch it the moment it comes, it will push it through Kafka or directly to Spark Streaming or Flink or Storm. And there I could have written a logic, okay, match this transaction if this guy's limit is something or his last transaction made places outside India or something, trigger a mail to customer care. That is how you are getting this EMI calls also. When you make a big transaction, immediately they will call and say, do you want to convert to EMI, right? These guys are responsible for that.
So even in the stock market, when you do a stop loss,
Same. Stock market, very big example. Yeah, same thing. Because all real time, right? Because tomorrow if I get a message for today's stop loss, doesn't make any sense, right? Now, since you are interested in this, I think in your Spark course, streaming is not there, very bad. Okay, but I can give you some example because what is the difference? This Storm can process one event also, meaning one credit card transaction Storm can process. Ideally, one credit card transaction it will process, minute. Spark Streaming can process only bunch. It cannot process one, meaning it will collect probably 2 seconds worth of all the transaction and predict. So that's called micro batching. It is creating a batch and then from that it is processing. Near real time, exactly. 100% real time is only possible with Storm. And Flink also does the same, I think. I know there are a lot of information I'm passing and a lot of you are actually almost like dead by hearing these terms and all. But I can't really help it because I'm not making it up. You can Google for that, okay? And probably now it may not make sense if you're listening to me, but probably later when you start working, if somebody talks about Spark Streaming and a use case, you will think, okay. Oh, this is what he spoke at that. So ICICI Bank's use case was that if somebody is clicking, they wrote a Spark Streaming code. Okay, now I have a question for you. Yeah.
for example, ICICI Securities there, ICICI Bank is there.
Ah.
You make a purchase for them, then there's a real-time transaction to my core bank.
Huh.
And also to my other kind of SMS and all those.
Huh. No, this securities we were not handling. I am not 100% sure how it is working. Our use case was only limited to this, right? But now I have a question. Okay, the question is very much valid. You are making a credit card transaction and Spark Streaming catches it. Spark Streaming catches it, but that is the real-time transaction. How does it know that this is a fraud based on the previous transaction? Fine. Yeah, the batch data is there. But how it is working? Machine learning. They could have built a machine learning model, profiling all your past within Hadoop only.
No, within, I mean, but within Spark or because it
Spark, MLlib.
but it needs some historical data for that, right?
Yeah, they already have historical data. All these customers' transaction is here. These are all on top of HDFS only. This is running on top of HDFS only. This is part of HDFS. Huh?
You'll be able to query the directly without problem.
When you install Spark, exactly. So Spark is getting installed on top of Hadoop only. HDFS is the storage for Spark. So if I am making a credit card transaction today, all my previous transactions are already here. They could have already built a machine learning model, and if you simply feed this new transaction, it can predict. Otherwise, how do you compare with batch data? I cannot run a batch job. It will take a lot of time, right? All the customer data. So they will run a MLlib. It's called MLlib in Spark. Machine learning model will be running. That will easily compare and say it's a fraud. You know? If you want to compare the batch. Otherwise, see, now I am just making a transaction, right? It has to compare with my previous transactions to understand whether I am a fraud. So like he said, I was traveling only within Chennai for the last 10 years. Today I am swiping in New York. So New York swipe, if you want to understand it is an anomaly, you should compare it with previous swipe, right? Now each time you cannot go and compare for each customer. So they build a machine learning model based on all this data that can, if you feed a data, it can predict, you know, whether he will be a fraud or not. Kafka, okay, so Kafka will not send, Spark will get, because it is a publish subscribe system. It is called Spark streaming is an application which will poll a Kafka topic and get it from Kafka. It will get
By
it.
the way, the Spark pulling the data from the Kafka.
Fine.
Okay. But you again said a Spark has been built on the HDFS.
Correct.
Why do we need to
HDFS is not a storage system.
No, this is your permanent storage. Spark can read from here, also from here. Spark can read from a variety of sources.
Okay, so the data what is the Kafka will never store only for the minute period of time.
Like 1 week by default. So this is your real-time data.
Yeah, that's correct.
Right. I'm just reading it to get my current information. All my original information is going here only, right? The golden copy is here. So if tomorrow I want to run a Spark job, yesterday's data, I can read from HDFS.
So machine learning will happen with a Spark streaming using the HDFS.
So this original data will get from here, current data, and there will be a machine learning model which is already built based on this data. It will not read the data. The model could have already read and learned. That is, so you guys have to teach me this. You are learning machine learning, right? Not me. You have to tell me how it is working, right? How would I am a data engineer. So what is your machine learning, right? Your topic is machine learning, right?
So what you're saying in securities, if I buy 1 year ago, that is my historical data, today's price is my current data, and what Spark will do is a loss comparison.
No. I am saying in this HDFS, you have all the transactions made by all the customers for last 1 year, credit card. That's a repository. You feed it to Spark's machine learning algorithm. It will build a model which, if you give any new data, it can predict whether it is fraud or not. It need not have to go here.
I didn't purchase for last 1 year. My purchase was 1 year ago. My purchase cost is there. Purchase cost is there next year.
That you have to adjust in the machine learning. That's what I'm saying.
Today's rate is available in the Kafka. And Spark will get me what is my loss and profit for the day.
No, it will not directly compare and get. This I'm talking only about fraud detection. So your use case is your this thing, right? Stock market price variation. Recommendation. Recommendation you can do.
Recommendation for, let's say, you can reduce your loss, or you can increase your, you can bid for a profit. This is the current profit.
No, historical purchase is there in HDFS. Today's price is there in Kafka. So I'm comparing 1 year old price, what have I bought, and today's price, what is the profit? It will compute and
You're computing a notional value. You're computing a notional value.
That's okay. So my point is, this historical data will be huge. It will be in terabytes, right? So you could have already created a machine learning model by feeding this data, which if you give any new data can predict whether it is fraud or not. That is happening in real time. I cannot say that once if somebody swipes a credit card, I will tell you whether it is fraud tomorrow. Doesn't make any sense, right? I have to do it immediately. Now, the flip side is that all this requires resources. Nothing is going to work if you don't have resources. So you need to give enough resources for all these things to work. Machine learning and all are very resource hungry. CPU power, RAM power, right? So these clusters should be capable of doing this. Anyway, for the time being, let's move on from Kafka, right? So we are just taking a use case, right? Now, I'll go here. Once your data is in HDFS, if you want to do batch processing, the default framework is MapReduce, MR. What is MapReduce? We will see tomorrow. But I have my data, I want to do batch processing. I don't care how much time it takes, 1 day can take. I just want to process the data, I can use something called MapReduce, right? You also have one more guy called Pig. This is almost gone from the market. Pig, the animal pig. Pig is a scripting tool on Hadoop, but not very popular now because of Spark. So nobody is actually, so even if you are not aware of Pig, it is perfectly fine, I think. Okay, you don't have to worry. And then you have somebody called Hive. This is there in your syllabus. So Hive I will teach in the next month, but basically what Hive allows you to do is to write SQL on top of Hadoop. But the drawback is you say create table and select count star from the table, hit the query. It will convert your query into a MapReduce program. So it's a translator. It is not a native SQL engine. Yeah, if I'm writing an Oracle query, Oracle will execute it for me. If I write a Hive query, MapReduce will execute it for me. So you will understand when we speak more about Hive, don't worry. So, C, exactly. So MapReduce itself is very slow because this is batch processing. In Hive, you write a SQL query and Hive will not execute your query. It will write a MapReduce program for you. Even more slower.
And there is a possibility to configure to Spark also, right? Hive to Spark.
Hive to Spark can be configured. Yeah. So, but the problem is Hive was the original tool. It was built in 2005 by Facebook. Okay. And at that point, it was very popular because there was no other tool. Right. So people were writing Hive queries. Even though it is slow, it is SQL, right? See, which is better? You can suffer some slowness or you have to learn Java. You can suffer SQL, right? Right. So ETL. 15 minutes, it is fine. Yeah. So Facebook developers thought that instead of learning Java, right, we will stick with SQL. ETL jobs we will run. They created this tool called Hive. So if I am a Hive developer, I don't have to learn anything. It's SQL. I say create table, join. But once I say join, it will write a MapReduce for me. Then the MapReduce will run. I may have to wait for. In fact, in Flipkart, there was a Hive query which took around 12 hours to run. Today they will fire, tomorrow they will get the result. 12 hours was the typical runtime. A huge amount of data, obviously. But then they fine-tuned it and all. But that's a different story. But so a lot of time, batch processing. So these are all batch processing systems built on top of Hadoop, right? And then you have Spark. You will learn Spark later. I don't want to confuse you a lot. So Spark is there. And this guy is inside Spark, okay? Even though I wrote it here, this guy is inside Spark. Spark is an in-memory execution engine. Spark is again classified as a batch processing system, but very, very fast than MapReduce. The only difference is that Spark programs are faster than MapReduce programs.
Rest of these are Spark can be able to handle real-time data.
Near real time, not real time. So Spark streaming is actually real time, but I will say near real time, not like 100% real time.
You mean to say when the buffer has been completed, it can't submit?
There will be a buffer always, like 1 second, 2 seconds. You can define that and it will process like that. I cannot have microsecond real time. That's not possible.
So basically, these other MR, Pig and Hive are obsolete?
So MR and Pig are obsolete. Hive is not obsolete because Hive is your data warehouse where you create tables and store the data. So this guy will remain, but now what is going to happen? Spark will connect with Hive. And Spark can write. So here you can write a SQL. Okay, Spark has a Spark SQL library. It can read tables from Hive and run on top of that, right? So Spark will start talking to Hive. So Hive is not really obsolete. Hive will be there for some time, we can say. No, HDFS. Storage is HDFS only. MR there is. Pig is gone. No, there is nothing. Pig is almost. Pig is a scripting tool. So Pig also will convert your query to MapReduce.
But Pig is obsolete, right? So,
Obsolete.
So like what is the new version?
Spark only. Not new version, Spark has practically replaced Pig actually. So this is your batch processing frameworks, right? Now, some other guys came and they said that, so that was a typical question that asked during the training. So if I want to run, okay, again there is a confusion. If I want to run a very big group by query, let's say I want to read the full table, scan and run a query, Hive is great. Even Spark SQL with Hive is great because they will read the whole data and process it. But if I have minute queries, let's say select something from the table where name equal to Raghuraman. Only one row it needs to process. For that, why should I load the full data and process? It is useless. But Hadoop says load everything in sequentially and then process. That is only possible. That is where you have this MPP engines. Impala. There is a one guy called Impala. There is another guy called Hawk. Hawk and LLAP. There is something called Presto. There is also something called what is that? Forgot the name. Drill. Phoenix. These are all MPP engines. Just be aware of the name. You don't have to be an expert on, like there is no chance where your manager will ask, okay, name the top 5 MPP engines or you're fired. Nothing is going to happen like that. Any one of them will be used actually. Impala is Cloudera specific. Cloudera created Impala. So it will be mostly available only on Cloudera. What Impala does is very simple. It has its own execution engine. You fire a SQL query, it will run it for you, no MapReduce. Right? So what is going to happen for these queries like where name equal to Raghuraman, you can fire an Impala query. It will scan only that data. Right? So it can connect with HDFS and pick only the data because it remembers the metadata. Where is what data available? It can columnar, it can pick that data and query. But then you will be wondering, why can't we use this instead of Hive? And these guys are very fast. So if these guys are too fast, then why don't I use them instead of Hive? They don't have reliability. They are all in-memory queries. If an Impala query is running in my Hadoop cluster, if any one of the machine crashes, my query will be gone. If a Hive query is running, even 10 machine crash, query will complete. It is MapReduce. Built-in redundancy is there. MapReduce will never fail, or Spark will never fail.
But even Spark also the lazy evaluation is there, right?
Yeah.
Suppose where name equals something, it takes
Correct.
that record only, right?
No. It is loading the whole data into memory. Then only analysis happens, right?
In the record case, suppose in Spark, I am going to find that particular select star from some table, where name equals something.
Correct.
If that file is name, it is going to read that record only, right?
No. Before, so when you say select star from this table, first that table data will be loaded into the RAM. Then only it reads from there, right? So initially the whole data is loaded.
In respect of whether the record is just one or not.
Exactly, that's the problem. But if I'm using Impala, okay, it has its own metadata, it knows where is the data, it loads only that and queries will be faster. So if I run an Impala query, considering a Hive query, Impala queries are much faster, but no fault tolerance. So for these very fast queries, like your queries can take like 2 minutes, 3 minutes time, you can afford to lose a query, use Impala. But if I'm having a ETL job where I don't want the job to fail, run it using Hive or Spark SQL because these guys will never fail.
It runs only in one machine, Impala.
It is distributed. It can run on n number of machines.
Even one system gets down, it can't able to.
Query will be gone because there is no. I will show you tomorrow in MapReduce. We will persist the data, intermediate results. That is how it is fault tolerant. Impala is all in memory. So if a machine crashes, that data is gone. What was in the RAM? Query will abort. So all MPP engines are like this, I think, in the traditional world also. In this, the difference is Impala is on Cloudera. Hawk and LLAP are Hortonworks. So there is a competition. Impala was originally created by Cloudera. So they promote it. If you are in a Cloudera platform, you will see Impala. If you are on a Hortonworks platform, you will never see Impala. They will promote Hawk. They will say Hawk is the best engine. Okay, and LLAP is the new version of Hawk. Presto, Drill and all are similar ones, but not by default available. This guy is very interesting. So there is something called HBase. I will add it here. Somebody was asking me what is HBase. HBase is your database of Hadoop. NoSQL database, real-time database, real-time. Because HBase will get installed on HDFS, there is your storage, right? But it can do random reads and writes, not like entire block. So normally when you are reading the data from HDFS, you have to read the whole block, right? But HBase has an API. So if you install HBase on top of Hadoop, it can do random reads and writes. Individual records it can read and write and process, because it is a NoSQL database of Hadoop, the default NoSQL database. But the drawback is HBase has its own language. So if somebody has to work with HBase, you have to learn the language. It will not allow SQL queries. Phoenix is SQL on HBase. Phoenix and HBase is like roti and paneer butter masala, deadly combination. I mean, very deadly combination because you are writing SQL on top of NoSQL, right? Very deadly. So they say that in another 2 years, it will not be slow. It is really fast because HBase itself is fast. SQL, there is a conversion, okay, but that's already built in. Any SQL query, there are some limitations, but most of the SQL, no, it will not fail. So Phoenix will get all the metadata, and already all the queries are converted. Whatever query SQL you are writing, it knows what is equivalent HBase query. It has just push the query. So you just write a SQL, it will run on HBase and give you the result. And it can do things like secondary indexes and all. It can index your data apart from HBase. It's very fast actually. Now the real news is that in another 2 years, what is predicted is that this combination, the drawback is Phoenix is still in alpha beta. Phoenix is not production ready. Once Phoenix becomes production ready, this is OLTP. It's OLTP. That means Hadoop will provide you OLAP and OLTP. Huh? It will support in future, not now. So they are trying to make it ACID support so that this entire combination will become an OLTP system like that, right? So then what will happen? You will get transaction management in Hadoop. So far it is not there. Another 2 years down the line, they say that. So Phoenix is getting integrated with HBase. Originally HBase was only there. The drawback is it doesn't understand SQL. So Phoenix started. Phoenix is a layer on top of that. You can write SQL. So in another 2 years, they are developing this as a system for transactional management. So you'll get true transactional management in Hadoop. So if you talk about these Cloudera and all, if I'm going to Cloudera and say that I want your product, they will give you all this in one package. But if you go to Apache and download, you get only HDFS, MapReduce and Yarn, only Hadoop. All this you have to separately install. So commercial distributions will package it and you will not get everything, okay. For example, Hawk will not be there. This Presto, Drill, Phoenix, you will get HBase, Hive, Pig, MapReduce, Spark, Impala. So these things you will get. You have a doubt, I'll show you that in the Cloudera page.
So that Spark runs SQL query.
Yes, there is something called Spark SQL where it runs SQL query. It is really fast actually.
We need Hive then.
That's what. The tables you will be creating in Hive. Spark doesn't have storage, right? So whatever tables you create there, it can connect and run. So I'll say Cloudera CDH. The HBase has its own processing engine. Its own processing engine. So this is Cloudera's product. Why I'm showing you this to tell you that I'm not blabbering. Okay, you may be thinking that this guy is talking about a lot of tools. Do they really exist in the world? Look at here. Look at here. Spark, Hive, Pig, MapReduce, Spark, Impala, Yarn, right? What you have? HDFS, HBase, Kafka, Flume, Scoop. This is a real product from Cloudera. You go to Cloudera, this is what you get. Some of them I have not even explained because I don't know. Kite, I don't know what it is, to be very honest. Kudu is a new file system, relational. Even I am not aware of Kudu. I don't know what it is. But these are like new entries. Even if you don't know them, you will work without any problem. And for security, you have something called Sentry. So a lot of people are worried about security on Hadoop, right? So there is a service called Sentry, which will handle like access management, authorization, authentication. All this will be handled by Sentry. We covered these things, right? These things we covered, this we covered, this we covered. Something extra I have wrote, I mean that is okay. I mean here this part, right? This Presto, Drill, Phoenix and all is not there, but I just wrote them. One thing which is not present there, but it comes, is Uzi. This I told you, right? This is the workflow scheduler. Like if you want to schedule a workflow and all, you can do that. I think we can do one thing. We have half an hour left and you are like almost tortured. I'll show you a Cloudera cluster. How about that? That will be better than talking a lot. So I keep on talking all this, right? So I'll show you a Cloudera cluster. We will not do the hands-on today. In the cluster we are using for the lab, we have only read-only access from the admin side, which means you cannot change the replication factor or block size or anything. These are all done by admins. We can upload the data and then say that run the program, that will work. But that we will do tomorrow. But let's look at the cluster, right? So far we are talking cluster and we are not seeing any cluster so far. So I think Cloudera, Hortonworks and Mapr, these three are getting used actually. All the three companies are sort of famous, I can say. Right? Okay. So do you have this in your LMS, like your lab and all? Just check once. Yeah. So because some of the things are a bit confusing, so I have to tell you, we have to use web console. Web console will connect with the Linux file system where Hadoop is installed. We will do that later. Cloudera Manager is the admin interface of the cluster. So I will connect with it, but we will not be able to modify, but we can see stuff. So if I go to Cloudera, Cloudera Manager is a utility that comes with Cloudera to administer the cluster. Like you want to add a service, remove a service, add a machine, remove a machine. So the administrator, if you are a Hadoop administrator, you have to do all these things, add users, remove users, permissions, everything can be done by Cloudera Manager. And why I did not speak about this, because we will not be doing anything using this, it's an admin utility. But to look at the cluster, this guy is good. So let me show you that. Cloudera Manager. Now you have to install it. So if I am running in a company, I have to purchase, let's say 20 machines. Physically, yeah. And then I have to, there is a process of installing Hadoop. This cluster already has installed. It is a running cluster. If you are creating from scratch, you have to purchase, let's say 20 machines and download something called Cloudera Manager and run it. And it will help you to set up the cluster. It will tell that which is your master, which is your slave, what is your block size, what is your...
Service like, I mean, if I don't have space, I want to use virtual systems. It is a company which is providing on cloud.
Cloud is also, this is physical, this is not even physical. This cluster is actually running on AWS, Amazon Web Services.
If you wanted to practice.
Practice.
Site which offers this kind of setup.
You will have access to this, right? I mean, if you want to practice, this setup is already available to you, right?
It's giving some bad requests if you try to log in.
Let me try to log in. Okay, just probably you don't have access. I don't know. Yeah. So just pay attention. So this is your Cloudera cluster. Okay, this is just an admin GUI. Okay, to the cluster, and once you log in, this is your dashboard. So you are looking at a Hadoop cluster. First point you have to understand. Second point, what is there in the Hadoop cluster? These are all the services installed. See, HDFS. Why am I talking like this? I can see it here, right? Okay, HDFS, Hive, Hue, I will talk about it. Impala, Kafka, Uzi, Solar, Spark, Yarn, Zookeeper, all these services are running in the cluster. You see a green, right? This is just to get a quick overview of the cluster, like what is running in the cluster. Fine. How many machines are there in the cluster? You click on this host menu. Can you see? Can you see these machines? These are all machines, 111, right? So how many machines are there? I think there are 9 machines. See, good health 9. 9 machines are there in the cluster. And you can also see their configuration. If I scroll here, can you see their RAM and hard disk? What is the physical memory? That is the RAM. The first 4 machines are 8 GB RAM. Next one is 16 GB RAM. These are their hard disk. Can you see? And you can see how much storage is full and all, everything, right? See here. So this guy is having 32 GB RAM and 18.8 is currently used. Some process will be running. This guy also had a 249 GB hard disk, 600 GB hard disk, 50 GB hard disk. You can all see from a single window. It's very easy. So it is not as complicated as you thought, by the way, right? So this is just the host menu, right? You can just from Cloudera Manager, this is the home page. Click on host. Host, you will see this, right? Now, if you look at HDFS, this is HDFS. Click on HDFS, okay? You will see this HDFS menu. This is all related to HDFS. In HDFS, what we learned, replication, block size. So where do you configure this? There is something called configuration. And do you want to change the, see, it is saying read only. I cannot change it. But do you want to see the replication factor of this cluster? DFS dot. What is the replication factor? 3. Click there, you can change it to 2 or 10 or whatever you want. If you are an admin, you are not an admin. Do you want to see the block size? DFS dot block size. Can you see? So I can click here and change if I am a Hadoop admin, and it will be applicable to everybody immediately and all. Somebody was asking about balancer, right? Where is balancer? I can say actions. Okay. The problem is that some of these things I will not be able to run. Where? Instances. This is balancer where it is running, but I can run a command. Sorry? It's not green. It is not running. If it is running, this process will come as green actually. Then chart commands, configuration. So there is a lot of configuration. Okay, so that is one thing we saw, and host menu we saw already, right? So far we discussed only HDFS, and here is Kafka. If I go to Kafka, let me just go to Kafka. Okay, Kafka says Kafka broker 3. That means 3 machines are running Kafka. I told you Kafka will be running in a cluster. Since this is a lab setup, we are running Kafka inside Hadoop only. Ideally, we run it separately because it needs storage spaces to hold your data. But here Kafka brokers are 3. We are running inside here only. Because this is only cluster we have. I mean, these machines, if I go to these machines, I will show you. If you go to this host menu, you can expand a host and see what it is doing. For example, if I expand this guy, see, what is it? It is your name node, right? So, and also I can go to HDFS and see that. For example, I go to HDFS and instances. What do you see here? Active standby, 2 machines, 2 name nodes. I told you, right? Active and standby, they are running, right? So the same machines are running Kafka here. It's not a separate cluster, by the way. That's what I meant by that. I don't have really admin access, otherwise something could have been done. I don't want to mess up the cluster also, by the way. So some of the menus are actually disabled. We can't run them. See. Exactly. Ideally, that should not be the case, because then it is not utilizing the proper space, right? So ideally, you will set up a separate broker, and that will download the data actually. They are all running on AWS actually. I don't know. I mean, I don't have access to that. Can be anywhere, doesn't matter. AWS, you can create a cluster anywhere. I don't have any idea as to who created this cluster and all. It's a third party. They just give access to us. Even I have only read-only access like you guys have. Now, this is to just brush up for tomorrow. Tomorrow we'll be actually doing it. But I want to clarify one more thing. If you go to this Big Data Cloud Lab, this Cloudera Manager you don't really need, because that's the admin interface. You are not going to do any admin activity. The important thing that you need is Web Console. So if you click on Web Console, I just clicked on that. For some reason it is not opening up. Let me just see. Do you guys see anything?
Yes.
Why am I not getting login? You can log in, but if I have to show, I have to log in, right? So where is Mohini? She is not here. Yeah, you can log in. That will connect you to one of the machines in the cluster, and you will see Linux. You can just log on to one of the machine. That is what you see there.
Yeah.
And I am not able to log on. You are getting the Linux shell. Take some time. No, I am taking long time. And there is a product called Hue. This is very important. There is a product called Hue. This Hue is a third-party application. Okay, but it is very, very popular. Why do you need Hue? Is that if you are a developer and you want to upload your files to Hadoop, you can use Hue. One of the use cases. For example, I can click this. I'll click Hue, and last the username and password. If I sign in, okay, I'll just sign in. If I click on this HDFS browser, see there, this is my Hadoop. These are all the files in my Hadoop. So Hue is like a web UI to your Hadoop, HDFS file system. So these are all the files and folders. If you connect, you will not see anything here because you are having a fresh account. One more very important point I want to tell you is that in Hadoop, you will have a home directory, user/something. I have GL faculty. You will have your own directory. Can you try this Hue thing on your PC? Just click on this Hue, type username, password, see whether you can see this thing. Are you able to see? Another point is that sometimes the cluster will become very slow because it is not designed to accept requests from 36 people. Right? If all of us try to log in, it will say timed out and other things. No? What username and password you are typing? Empty. That's fine. Because in your Hadoop home directory, there are no files. I have already ran something, so that is why these files are there. So we will create it tomorrow, don't worry. We will create it using
We are using the same data nodes individually for our own file management.
The same cluster. So different users are created in the Hadoop cluster. So if you log in, you will get a home directory, like in Linux. In Linux, what happens if you log on, you will get a home directory. So this is my home directory in HDFS. And since I already created some files, I can see them. You may not be able to see because it is a fresh home directory for you. Tomorrow I will show you how to upload the file, run a sample MapReduce program, explain the program and all. We will do that tomorrow, don't worry. So there were some unanswered questions. I said I will pick it up later. I forgot also. Anybody had any questions I pushed? Did I tell you I will show something and I forgot also some of the things? Correct. No, it will be in a non-commodity hardware, like a real server. The problem is I am not able to connect with the web console. See, it is not giving me option to connect. I need to connect to that to show you something. Hue, Kafka, Impala is running here. Okay, I missed a concept. I wanted to talk about it. It's a very important concept, right? Do you know what is a rack? You know what is a rack? Server rack? A rack is like a rack, right? How do you explain what is a rack? Even I don't know how to explain.
Used to fit in the storage devices.
Servers and all. Because from the point of view of Hadoop, this might be important. Sorry. I will explain this one and then pick up your questions. Images.google.com. So this is for people who do not know server rack. Do you know what is a rack now? This is a rack. It's a housing where you push all the servers. In all the hi-fi movies, you will say somebody sitting something, typing something in a very big data center and all, right? So that's a rack. Why racks are important? They are important for one reason, because can I erase this diagram, this one? Even I don't know what I wrote. Anyway, that's fine. So why racks are important is because of one particular reason. See, let's say you have 3 racks. You are having 3 racks, okay? And each rack has a data node. Not one, there are many. So let's say 2 data nodes are there. So in reality, when you are installing Hadoop in a cluster, this is how you do, right? Because in a data center you will have racks and you will have servers. These servers are called your data nodes, right? So I have 6 data nodes in 3 racks. Now there is something called rack awareness in Hadoop, meaning if let's say you are copying a block, what you can do, this first copy will go here, the second copy will go here, imagine, and the third copy will go here. Meaning if you enable this feature called rack awareness, Hadoop will ensure that the blocks are spread across multiple racks. Why? Yeah, a rack can fail. A rack is a point of failure, because normally you will supply this power and network, everything through rack. So if a rack fails, if I'm keeping all the 3 blocks in the same rack, if that rack fails, then my blocks are gone. So Hadoop can, if you enable rack awareness, you have to tell Hadoop which data node is in which rack. If you do that, it can place them like this. But why don't it keep like all 3 in 3 different racks? Why the rest of the 2 copies are in the same rack? Yeah, but same location means these are all in the same data center, right? So this inter-rack bandwidth is very important. Rack to rack, the bandwidth is very important. So this is just replication, right? You will be running a lot of programs which will use this bandwidth. So to save that bandwidth, what it does is that the next replication will happen within the rack, server to server. But this is enough. Now even if one rack and all the 3 racks going down is very remote possibility, right? And my point was, I can show you that here. So when I saw that, if you go to all host, can you see this? So in the rack 1, 4 are there, rack 2, 2 are there, rack 3, 2 are there, and default rack 2 are there. Default means I don't know, they have kept something here, but 4, 2, 2. So this is actually the distribution. It is actually available in your Cloudera manager. No. Each rack is not a system.
What you are going to do is just plugging just like one data node into that rack.
Not one, many will be in one rack, right? See here. All the masters will be in a separate rack. See, if you look at this picture, right? In this machine, some 30 data nodes will be there. Each slot you will have one server. They are all rack server. So server is not like this, it is like this. Like a pizza. You get a pizza. How does the pizza looks like? That is how a server will look like. Not like this. There is also that kind of server. Tower servers are there. But these servers typically we use are these kind of servers. I had a picture actually. Yahoo, Hadoop cluster at Yahoo. Hadoop cluster at Yahoo. So the biggest Hadoop cluster on earth is with Yahoo, actually. Yahoo holds the record for that. They have 42,000 machines. And still they went bankrupt, sold it to some useless company. So the picture is not visible actually, but you got the idea. This is no, that's a good question. So can I have multiple name nodes? Yes. The concept is called federation, meaning ideally if you cross more than 5,000 data nodes, you need one more name node. Like 42,000 machines, I cannot have a single name node to handle because the amount of metadata, it will become slow. That is a problem. So ideally, Yahoo has done some R&D. They said that if you cross more than 5,000 data nodes, you need one more data node. That's called name node. That's called federation. Federation means multiple active name nodes. Like you can have 10 name nodes, all will be working. They'll share the load actually, right? So like that. Federation is called it. Yeah, sorry. All in one rack actually you can put. Inside the same data center only you need all of them, right? Because all the data nodes are in one LAN, so the name node also should be inside that only. But they will handle the load actually. So some data nodes will be not to this name node and all. They can handle the load.
Can you have multiple?
Sorry, just a moment. File server can store, but it cannot process, right? That's the use case. Hadoop is not only for storing. Whatever data you store, the data can be processed then and there by the machine. Correct. Correct. So there we are not using Hadoop, right? We discussed it in the beginning of the class, NoSQL databases. If you don't want processing, if your use case is such that I just want to dump a bunch of images, let's say 1 million images, I just want to process and display in an e-commerce website, I don't use Hadoop. Hadoop is not used for that. There you have NoSQL databases like DynamoDB or MongoDB, right? SharePoint. If it is a smaller setup, SharePoint you can use. Right? Which one? Haystack. Haystack is built on top of this. Or top of this. Yeah. Facebook's, right? Correct. Correct. So it is all business use case. The question is that what do I want to do with the data? There are other companies who generate terabytes of data, they just archive the data. I just generate data, I don't want to analyze, I just archive the data, who cares? So it is up to me to decide what should I do with the data, right? For I was working with GE, very interesting use case. GE, right? The company called GE. I have a training next week there. So they have an aviation department. GE is building this aircraft engine, you know that? Flight engine. 80% of the commercial aircraft engines are from GE. And what they do, so most of the planes are flying with GE engine. There is also Rolls-Royce and one more company. So all these aircraft engines are having sensors. So when the flight is flying, they capture the sensor data like pressure and blah blah blah, and they analyze it to predict when the flight will crash or turbulence will hit or something like that, whether you're going to die or something. So the idea is that, but so I said, okay, good deal, you're doing this. They said, no, it's not a good deal. The problem is if a flight is flying from, let's say, Dubai to Bangalore, there will be 2 engines. It takes 6 hours. Each engine will generate 1 TB data. How many flights are there in total and how many flights fly every day? Can you imagine the amount of data? They don't analyze. How can you analyze? I mean, if I'm giving you, let's say, 1000 terabyte every hour or every minute, you can't analyze it. So they take a subset of that. They have an algorithm which takes a subset of the data and analyze. Rest they delete and dump. Because it is not humanly possible. Also, you don't need that much amount. Every sensor data need not be analyzed. This is very interesting because they also have locomotive engines, train. All the Europe and US, they run trains. And these trains are having sensors, so they get also that. It's very difficult to work with GE because huge amount of data, they also don't know what to do with the data, right? And they have no clue how to make sense of the data. Locomotive data is huge actually. So the trains will generate a lot of data actually. So they get it and then they take it and clean it and just get only a part of the data and they analyze it. In Hadoop, you also have certain file formats. For example, Avro. You may not have heard about it. Avro is a file format we use only in Hadoop. Parquet, ORC. These are all used to compress and store your data in Hadoop. You can also have compression techniques, because sometimes storing the data as it is not good. Why don't you compress it? But what is the drawback of compression? You have to decompress. You need a lot of processing power if you want to decompress it. So Avro is a serialization format. It doesn't compress the data. Parquet and all will compress the data columnly and push the data. So I will show you in Hive when we discuss Hive. When you create a Hive table, you can say that the data has to be compressed. It will compress and store the data actually. And that is possible. So my point is, not everybody want to analyze all the data in the world. That is also humanly not. Think about Facebook, how much data they will be getting. Probably they are not analyzing the whole data, a subset of interesting data. That is all they will be doing. So any questions? We'll wind up at 6:30 I think, but before that we can pick up questions. Yes, Spark is memory intensive. Ideally, Spark requires RAM. So if you give RAM, it will perform better. If you don't give RAM, it will use hard disk. I mean, rest of the space it will use hard disk. Performance will be slightly degraded. So for streaming and all, we need lot of RAM. The problem is, Football World Cup is going to happen, right? Yes. Right? When? This year only, right? So let's say you want to write a program which will download all the tweets and find out the most favorite player for Football World Cup. Possible, right? So I can easily stream the data from Twitter. The problem is, I want to find out the most popular player every 5 minutes. Imagine. Probably not 5 minutes you want to do. So I want to get 5 minutes worth data, hold it in my memory and process. What if 5 minute data is so huge I cannot hold it in memory? Then it will be slow. Yes, I am just giving an imaginary situation where if 5 minutes worth data is in terabytes, you can't hold it actually. Not only Twitter, any data that you have, then you might want to persist into disk some of the data. Then processing will become slow. It is not real time then. So when you are running Spark streaming and all, your RAM should be available. Otherwise, it will become very slow. Today's match you will predict tomorrow, right? So things like that can happen. So that's not really good actually. So a lot of considerations are there where you have to use all these things. So I think we will wind up. What do you think? Yeah. So it's almost 6:30, and also.
Everything that you taught today is included in the slide pack.
Yes. So I will be sharing slides, also books. So there are a couple of good books written on Hadoop, which will give you a lot of idea about basics like how HDFS is working or all these things actually.
How much in depth do we need to understand it to basically complete successfully?
So I would say whatever I am training here is enough, but go through the book also. Say for example HDFS, you don't have to be an expert on high availability. See, there is an active name node and standby name node. If the active fails, standby will take over. How that happens, there is a process. So probably that topic, even if you don't know, it is not a big deal because that's an admin topic. If you are a Hadoop admin, you should know how that should work. But since you are a developer, you don't have to go in depth into those topics actually. So MapReduce and Hive should be more than enough, I think. And you are building this awareness to learn Spark. The basic idea is that you are building this so you can look at Spark. So I will say concentrate on Spark.
This brings us to the end of this Big Data Hadoop tutorial for beginners. Now, before you guys sign off, I'd like to inform you that we have launched a completely free learning platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. So guys, thank you very much for attending the session and have a great learning ahead.